Good morning from Mission Control Houston inside the Artemis Flight Control Room here at the Johnson Space Center. We are in a mission elapsed time of 1 day, 13 hours, 25 minutes and counting of the Artemis II mission. I'm Nilofer Ramji with NASA Communications. The Orbit 3 flight team is currently on console supporting the crew's sleep period. This is a planning shift where we go through all of the different motions to make sure the crew is ready and able to support their next flight day. The Orion spacecraft is currently 79,000 miles and counting away from Earth and 175,000 miles away from the Moon. The Artemis II astronauts, as I mentioned, are currently asleep aboard the Orion spacecraft named Integrity. They began their sleep shift at around a mission elapsed time of 1 day, 9 hours and 30 minutes, and it will last until a mission elapsed time of 1 day and 18 hours. The crew had a really busy day yesterday where they went through translunar injection. That TLI burn or translunar injection burn completed yesterday at 6:49 p.m. Central Time. The spacecraft ignited its main engine on the service module for 5 minutes and 49 seconds to get on a path to fly around the moon and bring us back to splashdown off the coast of the Pacific. You are seeing two live views on your screen right now. The left image that you see on your screen are live views coming in from the Integrity spacecraft. The crescent shape that you see there is actually our home planet, our Earth. The light is coming from the sun, of course, and that portion of the Earth is in daytime, while the shadow that's cast on the other side of the Earth, that portion of the Earth is in nighttime. On the right side of your screen, you can see our Artemis Flight Control Room. The team here is busy monitoring the vehicle and making sure systems are nominal while the crew gets some much-deserved rest. All right, and on your screen right now, you can see our various members of our flight control team. The two individuals on the left side of the screen are our capsule communicators, or our CAPCOMs. They are the ground support that talks to the crew if they need anything in orbit. The CAPCOMs that you see in the blue, first we have in the blue, we have Tess Caswell, and then next to Tess, we have Mike Savinsky. Next to Mike is our flight director for Orbit 3 this morning. That is Rick Henfling. This is our flight control team, along with several other flight controllers who are monitoring activities and this Artemis II mission. Good morning. This is Mission Control Houston. You are seeing a couple of different things on your screen right now, but let me start with the fact that we are exactly 1 day, 14 hours and 0 minutes into the mission elapsed time. And we have some spectacular views coming in right now of the Orion spacecraft. The view is coming in and out as we stabilize the cameras, but that is why you are seeing some of the blue screens that pop up. We'll continue to keep that view up as the solar array cameras adjust. So there is our Integrity spacecraft coming in and out. And on the right side of your screen, you can see our data visualization of the Orion spacecraft. You can see this at any point in time if you wish by going to nasa.gov/track Artemis. Like I mentioned, we are in a mission elapsed time of 1 day and 14 hours and counting. The spacecraft rather is 82,000 miles away from the Earth and 173 miles and counting away from the Moon. Now, the crew right now is taking some much-deserved rest, so as this camera configuration stabilizes more and more, we are going to take a look back on what's taken place over the course of the last flight day.
And Integrity Houston, we do have you on video for the 4K encoder checkout.
That is great news. Stand by for audio checks with the wireless mic.
Copy.
6 hours and 10 minutes since liftoff.
Amy, I just did audio with the wireless mic. Did you copy?
We have good audio. And we copy good audio on the handheld mic.
That is great news. We're ready to call 4K encoder checkout complete if you are.
We concur. 4K checkout complete, and whenever you're ready, I have some words about S-band string swap that we're interested in having you all perform. And it's great to see you all wave, 4 smiling voices, and we are really enjoying seeing you up there.
Not as much as we're enjoying being here.
That is true.
This view on your screen coming from Orion, looking back at all of us on Earth. This is coming from a camera mounted on one of the spacecraft's solar array wings. Just a little crescent Earth. Now 6 hours and 12 minutes since launch. The first flight of humans aboard Orion.
Houston Integrity on 1 for fan speed / cabin temperature.
Houston's listening.
Amy, is it possible to lower the cabin fan speed a bit? There's a lot of airflow in here, and if that is not possible, can we increase the temperature?
Copy, Reed. We understand the request, and we are discussing how to implement. We'll follow up.
Yeah, sounds good. No urgency there, but just know that will be our desire down the road.
Copy.
Now that the crew is awake, they are going to step into a brief post-sleep period, and then they will begin preparing for the perigee raise burn, or PRB burn. That burn is scheduled to take place in just under an hour from now, about 59 minutes until that burn ignition start.
Houston Integrity, good morning. We are with you for PRB ops.
And Integrity and Christina, good morning to y'all as well. Things are progressing well with PRB ops. We can do a quick tag up here shortly once we get our story ready.
And this is Mission Control Houston. You just heard a little bit of communication there on the Orion to Earth loop, and that is the voice link between the ground and the Orion spacecraft. So that was NASA astronaut Christina Cook, who is one of the mission specialists aboard the Orion spacecraft. Again, there are 4 crew members currently living and working on the Orion spacecraft as part of the Artemis II mission. So Christina was speaking directly with the team here in Mission Control Houston, specifically the CAPCOM or capsule communicator, and that flight control position serves as the direct voice link between the crew and the ground.
Houston Integrity for cabin temps.
Hey, go ahead, Christina.
Yes, it is very cold in the cabin. Any chance you can make it warmer or reduce the cabin fan speed a bit more so the ventilation is not blowing as hard?
Yeah, Christina, understand. While y'all were asleep, we did turn one of our knobs that we have, and that was and we saw a very small increase in the temperature. And so we're going to take a look at some of these shell heaters, and we'll let you know when we start putting some of that in work, and we can see if that affects the temperature in a positive way.
Our next check with you is for your go, no-go confirmation.
And Christina, Houston is go for the burn.
Integrity copies.
Integrity Houston, the solar arrays are in position for the burn.
Integrity copies.
And this is Mission Control Houston. We are about 1 minute out from the perigee raise burn. That burn expected to last about a minute. The burn will adjust Orion's perigee, or the lowest point of its orbit, into the correct orbital geometry to set it up for its translunar injection, or TLI burn. And that perigee raise burn is now underway. And there on your screen, you can see the 8 Pulse-X engines on the Orion spacecraft. Now, this is a visualization of the Orion spacecraft, as we don't currently have live views from the spacecraft itself, but this uses the data and telemetry from the spacecraft. Again, this perigee raise burn expected to last about a minute. Currently, everything is proceeding as planned. And we do have confirmation that that burn is complete. It was a good burn.
We're tracking a good burn.
And we see the same, and with a bonus trim burn.
And there on your screen, you are seeing a live view of the Orion spacecraft from one of its solar array wing cameras, and you can also see another one of the solar array wings on the bottom right hand of your screen from the Orion spacecraft. Again, this live view comes following that perigee raise burn.
Support there. We really appreciate it. It's been a good first. Well, it's been 2 orbits of Earth, I guess, and this one's just got a 38,000 mile apogee. We're going to pick up in 26-1-100 pre-sleep checklist, and then we're going to dim the cabin down and get some rest. Thanks for your support.
Yes, great PRB day. Excellent flight day 1, y'all. Get some good rest, and we'll be in touch in a couple hours.
You as well. Good night, Earth.
Good morning, Artemis II crew. While you're soaring beyond Earth, we're sending a little piece of home your way. Here are some messages from your NASA team to brighten your flight day.
From your friends in the R3 Flight Systems Branch, we are go for exercise.
Godspeed, Artemis II. Let's go fly from the Orion Engineering team. Woo!
Wishing you an excellent mission around the moon from the Huntsville Operations Support Center's Systems Engineering Team. Go Artemis!
From the Marshall Space Flight Center Earth Science Branch to the crew of Artemis II.
We wish you success. Bring back some perspective.
We just wanted to wish you a safe trip to the moon from your JSD SWAT team.
From the Wallops Island Radar 5 crew, go Artemis, Godspeed.
Good luck from your Orion mission planning team.
The IMAP team wishes you a safe journey.
Go Artemis II!
From all of us at NASA's Launch Services Program,
we're so proud to support the journey to the moon.
Go Artemis!
Houston Integrity, we are ready to go, and that was awesome. Thank you for all of those messages.
you are very welcome.
Good afternoon and welcome to the Artemis Flight Control Room here at NASA's Johnson Space Center in Houston, Texas. I'm NASA PAO Leah Cheshire Mustachio, your Orbit 1 commentator, ready to take you through a very busy day for the crew, namely with the translunar injection burn this afternoon. That is scheduled for 6:49 p.m. Central Time, expecting a 5-minute and 49-second burn on the OMS engine. On the left, the data visualization you're seeing is ARROW, the Artemis Real-Time Orbit website. If you look closely, you can see we are now under 10,000 miles away from Earth. That will continue to decrease until we get to 115 statute miles above our home planet. That'll be the closest the crew is to the planet until they return for their splashdown on flight day 10.
Integrity. Houston has completed the poll for TLI. When the engine ignites, you embark on humanity's lunar homecoming arc and set the course to return Integrity and her crew safely home. Houston is go for TLI.
Integrity copies, and your Integrity crew is go for TLI. With this burn to the moon, we do not leave Earth, we choose it.
Mission control is go. The crew is go. You're getting a live view from Orion now of Earth. Ten seconds until translunar injection burn start.
Integrity, good engine, good control.
We show the same. Feels great up here.
At MET, mission elapsed time of 1 day, 1 hour, and 14 minutes into the Artemis II mission. As Orion was flying 115 statute miles above Earth and 247,600 miles away from the moon, we have the start of the translunar injection burn that will send the crew around the moon, the first humans to do so in over 50 years. Velocity of the spacecraft ticking up, now over 23,900 miles per hour. 2 minutes into this 5-minute and 50 second burn. Continuing to get good calls here in Mission Control Houston from all flight controllers.
Integrity, we copy the enabled caution, no crew action.
Integrity copies.
Over 3 minutes now into the translunar injection burn. These live views coming from Orion as it looks back on Earth, leaving high Earth orbit and beginning its journey to the moon. We are now 230 miles above Earth, 246,500 miles away from the moon. We have 1 minute left in the translunar injection burn. Everything continuing to look good. We have less than 20 seconds left of this burn. This is the final major burn for the mission because this also serves as our deorbit burn.
Integrity looks like a good burn. We're confirming.
Integrity copies.
Confirmation from teams here on the ground to the Artemis II crew aboard Orion. We have translunar injection burn cutoff and early reports that it was a very good burn. Orion now 520 miles away from Earth. Just 5 minutes ago, we were only 115 miles above Earth's surface. That distance will continue to increase as we are now on a trajectory to fly around the moon for the first time in over 50 years. Live views from the Orion spacecraft as it looks back on Earth following completion of the translunar injection burn, the burn that commits us to flying around the moon. It also commits us to a return to our home planet on flight day 10 and a splashdown in the Pacific Ocean. But for now, these views of Earth as Orion starts its journey.
Houston Integrity, we just wanted to share a little bit of the sentiment up here as we came around the planet, and we're zooming over just 100 nautical miles above it if you got a moment.
Please, Jeremy, we are all ears.
Well, with that successful TLI, the crew's feeling pretty good up here on our way to the moon, and we just wanted to communicate to everyone around the planet who's worked to make Artemis possible that we firmly felt the power of your perseverance during every second of that burn. Humanity has once again shown what we are capable of, and it's your hopes for the future that carry us now on this journey around the moon.
Hugs there at the Capcom console from NASA astronaut and Capcom, or capsule communicator, Chris Birch, with Artemis II backup and Canadian Space Agency astronaut Jenny Gibbons. This is a live view from the Orion capsule looking back on Earth, our home planet. We are now 18,500 miles away from Earth. When we conducted that translunar injection burn coming up on about 2 hours ago, we were just 115 miles above our planet. Obviously, that has increased exponentially as we are now on the journey to the moon and back home. Currently, Orion is 223,000 miles away from the moon. This is Artemis Mission Control, now MET, or mission elapsed time, 1 day, 3 hours, and 10 minutes into the Artemis II mission, the first flight of humans around the moon in over 50 years. And we are going to the moon. After a successful translunar injection burn today, we are now over 19,500 miles away from Earth and growing closer to our lunar neighbor, now 222,000 miles away from the moon. The view on the left side of your screen is from Orion, a live view looking back at our home planet, that small dot. And down in the bottom right-hand screen, you can see Capcom Chris Birch wrapping up her Orbit 1 shift today, as well as Flight Director Jeff Radigan. They've been leading the teams throughout Orbit 1 and the translunar injection burn.
Integrity Houston, you ready for the event?
Houston Integrity, we are ready for the event.
ABC News, this is Mission Control Houston. Please call Integrity for a voice check.
Integrity, this is Gio Benitez at ABC News. How do you hear me?
Outstanding. We have you loud and clear. How about us?
I hear you loud and clear, and I truly cannot believe it. You are quite literally on the way to the moon right now and still speaking with us. Tell me, how do you feel? What's going through your mind? I mean, this must be so incredible because have you allowed the weight of the moment to really fit in here? Have you allowed that to happen?
Well, first and foremost, we all wanted to give a shout out to our families first because we are pretty far from Earth and we have not gotten to say hi to them yet. But there was a moment about an hour ago where Mission Control Houston reoriented our spacecraft as the sun was setting behind the Earth. And I don't know what we all expected to see in that moment, but you could see the entire globe from pole to pole. You could see Africa, Europe, and if you looked really close, you could see the northern lights. It was the most spectacular moment, and it paused all four of us in our tracks.
Yeah, well, you are making history. Reed Weissman, Christina Koch, Jeremy Hansen, Victor Glover. Congratulations to all of you. America, the world is with you. We are watching every moment of this journey, and we will cheer you when you get back and along the way. Thank you for joining us. Best of luck to you, and safe travels.
This is Mission Control Houston in the Artemis Flight Control Room at a mission elapsed time of 1 day, 14 hours, 21 minutes, and counting. We are coming to you live with our 24/7 continuous coverage. Currently, the Orion spacecraft is 83,000 miles away from Earth and 172,000 miles away from the Moon. As we go over the course of the rest of this flight day and coming into the next flight day when the crew will wake up, you will see the distance from Earth increase and the distance to the Moon decrease. And that means that we are getting ready to fly around the Moon on flight day 6. The crew performed the trans-lunar injection burn yesterday at 6:49 p.m. Central Time, where the spacecraft ignited its main engine on the service module for 5 minutes and 49 seconds to get on a path to fly around the Moon, as I shared, and then to splash down off the coast of the Pacific Ocean. Following the TLI burn, the crew had lunch and completed several activities, including space adaptation, to get them more comfortable to being in the microgravity environment. The crew also did some exercise, completed a public affairs event, and a window inspection. They then began their first official long sleep period, and they are currently sleeping. For now, this is Mission Control Houston. We hope that you enjoy the data visualization of the Orion telemetry, where Orion is with distance from the Earth and the Moon and the Sun in the background. You can check this out yourself by visiting nasa.gov/track-Artemis. For now, this is Mission Control Houston.
Houston, any corrections on the coast maneuver stuck enabled caution?
No action for the coast maneuver stuck caution.
Integrity.
Hey, all this was a result of the maneuver we're doing for the service module survey we're doing right now. Didn't predict that to happen. We apologize. Y'all can head back to bed.
Thank you.
This is Mission Control Houston coming to you live from the Artemis control room or flight control room. You are hearing, you just heard a conversation between Commander Reed Weissman and the ground here. Essentially what is happening on the ground is we are conducting a surveying activity where we are moving the solar array wings on the Orion spacecraft to face the crew module and service module. Those are the two items that you're seeing in our data visualization on the screen right now. What the team is essentially doing right now is they are surveying the spacecraft for any damage post-launch. If there's any damage, the team would be able to see that, and unfortunately that caused a little bit of a noise inside the cabin, and that is why you heard Commander call up during his sleep. The crew is doing this on the ground. The crew is doing this on the ground currently, to just survey, as I mentioned, and then once we do the lunar flyby, the same surveying activity will take place once again to make sure there is no damage post-lunar flyby. For now, coming to you live, this is Mission Control Houston. Good morning from Mission Control Houston. You are seeing live views right now from one of the solar array wings aboard the Orion spacecraft. As mentioned not too long ago, there is a surveying activity taking place while the crew is asleep. This is where the flight control teams on the ground here maneuver the solar array wings to take a look at the command module, which is sort of on the top left side of your screen, as well as the service module, which is on the bottom part of the spacecraft. This surveying activity essentially checks for any damage post-launch. The flight control team on the ground will conduct an additional surveying activity post-lunar flyby. For now, this is Mission Control Houston. And there you have it, the iconic NASA worm logo coming into view. As the team continues its surveying activity of the Integrity spacecraft. The top part of the vehicle where you do see the NASA worm logo is the crew module, and below that is the European Space Agency's service module. As we stabilize and configure these cameras to survey for any damage post-launch, you might see some distorted or pixelated images coming down. But this is coming to you live from the Integrity spacecraft at a mission elapsed time of 1 day, 14 hours, and 36 minutes and counting. Good morning from the Artemis Flight Control Room here in Mission Control Houston. I'm Nilofer Ramji with NASA Communications. As part of your Orbit 3 flight control team, we are coming to you live with 24/7 continuous coverage of the Artemis II mission. At a mission elapsed time of 1 day, 14 hours, 50 minutes, and counting, the crew is in their sleep period and they're expected to wake up just under 3 hours from now. As we wake up on this side of the planet, we are happy to share the first downlinked images from the Artemis II astronauts. These images were taken on Commander Reed Weissman's personal computing device, PCD or tablet. We have a spectacular high-resolution shot from inside the Orion cabin from one of the windows. And there it is, our home planet, looking back at the crew as they make their way towards the moon. There we have our image back, but we see our pale blue dot seen through the crew's eyes, and suddenly we're up there with them. Humanity is cheering, not just for the crew, but for what they have carried with them, and that's all of us. We also have a second image that was taken by our Commander Reed Weissman. Our home planet is watching and cheering them as they get closer to the moon. In this single frame, it wasn't Earth that they just captured. It was a reminder that no matter how far we go, we are still one world, watching, hoping, and reaching higher. We'll leave you with this image for a couple of minutes, but for now, this is Mission Control Houston. Good morning from the Artemis Flight Control Room here in Houston. At a mission elapsed time of 1 day, 15 hours, and 35 minutes, we are coming to you live with our 24/7 continuous coverage of the Artemis II mission. The crew is getting their first night's full sleep, and they are currently fast asleep while we are doing a surveying activity. So on the left side of your screen, you will see the solar array wing cameras pointed towards the spacecraft. The team on the ground, while the crew sleeps, is checking to see if there was any damage sustained to the vehicle over the course of launch. The team will conduct the same surveying activity following lunar flyby prior to splashdown. Now, for now, as the crew sleeps, let's take a look back on flight day 2 and the highlights from that flight. This is Mission Control Houston.
And Integrity Houston, we do have you on video for the 4K encoder checkout.
That is great news. Stand by for audio checks with the wireless mic.
Copy.
6 hours and 10 minutes since liftoff.
Amy, I just did audio with the wireless mic. Did you copy?
You have good audio on.
And we copy good audio on the handheld mic.
That is great news. We're ready to call 4K encoder checkout complete if you are.
We concur. 4K checkout complete, and whenever you're ready, I have some words about S-band string swap that we're interested in having you all perform. And it is great to see you all wave, 4 smiling voices, and we are really enjoying seeing you up there.
Not as much as we're enjoying being here.
That is true.
This view on your screen coming from Orion, looking back at all of us on Earth. This is coming from a camera mounted on one of the spacecraft's solar array wings. Just a little crescent Earth. Now 6 hours and 12 minutes since launch. The first flight of humans aboard Orion.
Houston Integrity on 1 for fan speed / cabin temperature.
Houston's listening.
Amy, is it possible to lower the cabin fan speed a bit? There's a lot of airflow in here, and if that is not possible, can we increase the temperature?
Copy, Reed. We understand the request, and we are discussing how to implement. We'll follow up.
Yeah, sounds good. No urgency there, but just know that will be our desire down the road.
Copy.
Now that the crew is awake, they are going to step into a brief post-sleep period, and then they will begin preparing for the perigee raise burn, or PRB burn. That burn is scheduled to take place in just under an hour from now, about 59 minutes until that burn ignition start.
Houston Integrity, good morning. We are with you for PRB ops.
And Integrity and Christina, good morning to y'all as well. Things are progressing well with PRB ops. We can do a quick tag up here shortly once we get our story ready.
And this is Mission Control Houston. You just heard a little bit of communication there on the Orion to Earth loop, and that is the voice link between the ground and the Orion spacecraft. So that was NASA astronaut Christina Cook, who is one of the mission specialists aboard the Orion spacecraft. Again, there are 4 crew members currently living and working on the Orion spacecraft as part of the Artemis II mission. So Christina was speaking directly with the team here in Mission Control Houston, specifically the CAPCOM, or capsule communicator, and that flight control position serves as the direct voice link between the crew and the ground.
Houston Integrity for cabin temps.
Hey, go ahead, Christina.
Yes, it is very cold in the cabin. Any chance you can make it warmer or reduce the cabin fan speed a bit more so the ventilation is not blowing as hard?
Yeah, Christina, understand. While y'all were asleep, we did turn one of our knobs that we have, and that was the rad loop set points. And we saw a very small increase in the temperature. And so we're going to take a look at some of these shell heaters, and we'll let you know when we start putting some of that in work, and we can see if that affects the temperature in a positive way.
Our next check with you is for your go, no-go confirmation.
And Christina, Houston is go for the burn.
Integrity copies.
Integrity Houston, the solar arrays are in position for the burn.
Integrity copies.
And this is Mission Control Houston. We are about 1 minute out from the perigee raise burn. That burn expected to last about a minute. The burn will adjust Orion's perigee, or the lowest point of its orbit, into the correct orbital geometry to set it up for its translunar injection, or TLI burn. And that perigee raise burn is now underway. And there on your screen, you can see the 8 Pulse-X engines on the Orion spacecraft. Now, this is a visualization of the Orion spacecraft, as we don't currently have live views from the spacecraft itself, but this uses the data and telemetry from the spacecraft. Again, this perigee raise burn expected to last about a minute. Currently, everything is proceeding as planned. And we do have confirmation that that burn is complete. It was a good burn.
We're tracking a good burn.
And we see the same, and with a bonus trim burn.
And there on your screen, you are seeing a live view of the Orion spacecraft from one of its solar array wing cameras, and you can also see another one of the solar array wings on the bottom right hand of your screen from the Orion spacecraft. Again, this live view comes following that perigee raise burn.
Support there. We really appreciate it. It's been a good first. Well, it's been 2 orbits of Earth, I guess, and this one's just got a 38,000 mile apogee. We're going to pick up in 26-1-100 pre-sleep checklist, and then we're going to dim the cabin down and get some rest. Thanks for your support.
Yes, great PRB day. Excellent flight day 1, y'all. Get some good rest, and we'll be in touch in a couple hours.
You as well. Good night, Earth.
Good morning, Artemis II crew. While you're soaring beyond Earth, we're sending a little piece of home your way. Here are some messages from your NASA team to brighten your flight day.
From your friends in Nera 3 Flight Systems Branch, we are go for exercise.
Godspeed, Artemis II. Let's go fly from the Orion Engineering team.
Wishing you an excellent mission around the moon from the Huntsville Operations Support Center's Systems Engineering team. Go Artemis!
From the Marshall Space Flight Center Earth Science Branch to the crew of Artemis II.
We wish you success. Bringing back some perspective.
We just wanted to wish you a safe trip to the moon from your JSD SWAT team.
From the Wallops Island Radar 5 crew, go Artemis. Godspeed.
Good luck from your Orion mission planning team.
IMAP team wishes you a safe journey.
Go Artemis II!
From all of us at NASA's Launch Services Program,
we're so proud to support the journey to the moon.
Go Artemis!
ready to go, and that was awesome. Thank you for all of those messages.
You are very welcome.
Good afternoon and welcome to the Artemis Flight Control Room here at NASA's Johnson Space Center in Houston, Texas. I'm NASA PAO Leah Cheshire Mustachio, your Orbit 1 commentator, ready to take you through a very busy day for the crew, namely with the translunar injection burn this afternoon. That is scheduled for 6:49 p.m. Central Time, expecting a 5-minute and 49-second burn on the OMS engine. On the left, the data visualization you're seeing is ARROW, the Artemis real-time orbit website. If you look closely, you can see we are now under 10,000 miles away from Earth. That will continue to decrease until we get to 115 statute miles above our home planet. That'll be the closest the crew is to the planet until they return for their splashdown on flight day 10.
Integrity. Houston has completed the poll for TLI. When the engine ignites, you embark on humanity's lunar homecoming arc and set the course to return Integrity and her crew safely home. Houston is go for TLI.
Integrity copies, and your Integrity crew is go for TLI. With this burn to the moon, we do not leave Earth, we choose it.
Mission control is go. The crew is go. You're getting a live view from Orion now of Earth. "10 seconds until translunar injection burns start.
Integrity. Good engine, good control.
We show the same. Feels great up here.
At MET, mission elapsed time of 1 day, 1 hour, and 14 minutes into the Artemis II mission. As Orion was flying 115 statute miles above Earth and 247,600 miles away from the moon, we have the start of the translunar injection burn that will send the crew around the moon, the first humans to do so in over 50 years. Velocity of the spacecraft ticking up, now over 23,900 miles per hour. 2 minutes into this 5-minute and 50 second burn. Continuing to get good calls here in Mission Control Houston from all flight controllers.
Integrity, we copy the enabled caution, no crew action.
Integrity copies.
Over 3 minutes now into the translunar injection burn. These live views coming from Orion as it looks back on Earth, leaving high Earth orbit and beginning its journey to the moon. We are now 230 miles above Earth, 246,500 miles away from the moon. We have 1 minute left in the translunar injection burn. Everything continuing to look good. We have less than 20 seconds left of this burn. This is the final major burn for the mission because this also serves as our deorbit burn.
Integrity looks like a good burn. We're confirming.
Integrity copies.
Confirmation from teams here on the ground to the Artemis II crew aboard Orion. We have translunar injection burn cutoff and early reports that it was a very good burn. Orion now 520 miles away from Earth. Just 5 minutes ago, we were only 115 miles above Earth's surface. That distance will continue to increase as we are now on a trajectory to fly around the moon for the first time in over 50 years. Live views from the Orion spacecraft as it looks back on Earth following completion of the translunar injection burn, the burn that commits us to flying around the moon. It also commits us to a return to our home planet on flight day 10 and a splashdown in the Pacific Ocean. But for now, these views of Earth as Orion starts its journey.
And Houston Integrity, we just wanted to share a little bit of the sentiment up here as we came around the planet, and we're zooming over just 100 nautical miles above it if you got a moment.
Please, Jeremy, we are all ears.
Well, with that successful TLI, the crew's feeling pretty good up here on our way to the moon, and we just wanted to communicate to everyone around the planet who's worked to make Artemis possible that we firmly felt the power of your perseverance during every second of that burn. Humanity has once again shown what we are capable of, and it's your hopes for the future that carry us now on this journey around the moon.
Hugs there at the Capcom console from NASA astronaut and Capcom, or capsule communicator, Chris Birch, with Artemis II backup and Canadian Space Agency astronaut Jenny Gibbons. This is a live view from the Orion capsule looking back on Earth, our home planet. We are now 18,500 miles away from Earth. When we conducted that translunar injection burn coming up on about 2 hours ago, we were just 115 miles above our planet. Obviously, that has increased exponentially as we are now on the journey to the moon and back home. Currently, Orion is 223,000 miles away from the moon. This is Artemis Mission Control, now MET, or mission elapsed time, 1 day, 3 hours, and 10 minutes into the Artemis II mission, the first flight of humans around the moon in over 50 years. And we are going to the moon. After a successful translunar injection burn today, we are now over 19,500 miles away from Earth and growing closer to our lunar neighbor, now 222,000 miles away from the moon. The view on the left side of your screen is from Orion, a live view looking back at our home planet, that small dot. And down in the bottom right-hand screen, you can see Capcom Chris Birch wrapping up her Orbit 1 shift today, as well as Flight Director Jeff Radigan. They've been leading the teams throughout Orbit 1 and the translunar injection burn.
Integrity Houston, you ready for the event?
Houston Integrity, we are ready for the event.
ABC News, this is Mission Control Houston. Please call Integrity for a voice check.
Integrity, this is Gio Benitez at ABC News. How do you hear me?
Outstanding. We have you loud and clear. How about us?
I hear you loud and clear, and I truly cannot believe it. You are quite literally on the way to the moon right now and still speaking with us. Tell me, how do you feel? What's going through your mind? I mean, this must be so incredible because have you allowed the weight of the moment to really fit in here? Have you allowed that to happen?
Well, first and foremost, we all wanted to give a shout out to our families first because we are pretty far from Earth and we have not gotten to say hi to them yet. But there was a moment about an hour ago where Mission Control Houston reoriented our spacecraft as the sun was setting behind the Earth. And I don't know what we all expected to see in that moment, but you could see the entire globe from pole to pole. You could see Africa, Europe, and if you looked really close, you could see the northern lights. It was the most spectacular moment, and it paused all four of us in our tracks.
Yeah, well, you are making history. Reed Wiseman, Christina Koch, Jeremy Hansen, Victor Glover. Congratulations to all of you. America, the world is with you. We are watching every moment of this journey, and we will cheer you when you get back and along the way. Thank you for joining us. Best of luck to you, and safe travels.
If you're just joining us, this is Mission Control Houston in the Artemis Flight Control Room here at the Johnson Space Center in Houston. At a mission elapsed time of 1 day, 16 hours, 9 minutes, and counting, we are coming to you live with our 24/7 coverage of the Artemis II mission. The crew is currently in their sleep period, so they're taking some much-deserved rest after TLI or translunar injection burn yesterday. These views coming to you live from the Orion Integrity spacecraft are of the solar array wings aboard the spacecraft. We have been doing a surveying activity as the crew sleeps. This essentially means that we are twisting and maneuvering each of the solar array wings one by one across the vehicle. There are 4 solar array wings, and we are surveying the crew module and the service module of the spacecraft for any damage or any issues post-launch. As the ground control teams in Orbit 3 are completing and conducting this survey, we will do an additional survey once the vehicle has flown around the moon. We will continue to provide live updates here in Mission Control. Good morning from Mission Control Houston inside the Artemis Flight Control Room here at the Johnson Space Center. We are at a mission elapsed time of 1 day, 16 hours, 28 minutes and counting of the Artemis II mission. The Orion spacecraft is currently 92,000 miles away from Earth and just over 166,000 miles away from the Moon. The Artemis II astronauts are currently asleep aboard the Orion spacecraft named Integrity. They began their sleep shift around a mission elapsed time of 1 day, 9 hours, and 30 minutes, and this will last through a mission elapsed time of 1 day, 18 hours. So while the crew wakes up in just a few short hours, we wanted to do a quick recap as to what took place yesterday. Here are your flight day highlights for flight day 2 of the mission.
And Integrity Houston, we do have you on video for the 4K encoder checkout.
That is great news. Stand by for audio checks with the wireless mic.
Copy.
6 hours and 10 minutes since liftoff.
Amy, I just did audio with the wireless mic. Did you copy?
You have good audio.
And we copy good audio on the handheld mic.
That is great news. We're ready to call 4K encoder checkout complete if you are.
We concur. 4K checkout complete, and whenever you're ready, I have some words about S-band string swap that we're interested in having y'all perform. And it is great to see you all wave, 4 smiling voices, and we are really enjoying seeing you up there.
Not as much as we're enjoying being here.
That is true.
This view on your screen coming from Orion, looking back at all of us on Earth. This is coming from a camera mounted on one of the spacecraft's solar array wings. Just a little crescent Earth. Now 6 hours and 12 minutes since launch. The first flight of humans aboard Orion.
Houston Integrity on 1 for fan speed / cabin temperature.
Houston's listening.
Amy, is it possible to lower the cabin fan speed a bit? There's a lot of airflow in here, and if that is not possible, can we increase the temperature?
Copy, Reed. We understand the request, and we are discussing how to implement. We'll follow up.
Yeah, sounds good. No urgency there, but just know that will be our desire down the road.
Copy.
Now that the crew is awake, they are going to step into a brief post-sleep period, and then they will begin preparing for the perigee raise burn, or PRB burn. That burn is scheduled to take place in just under an hour from now, about 59 minutes until that burn ignition start.
Houston Integrity, good morning. We are with you for PRB ops.
And Integrity and Christina, good morning to y'all as well. Things are progressing well with PRB ops. We can do a quick tag up here shortly once we get our story ready.
And this is Mission Control Houston. You just heard a little bit of communication there on the Orion to Earth loop, and that is the voice link between the ground and the Orion spacecraft. So that was NASA astronaut Christina Koch, who is one of the mission specialists aboard the Orion spacecraft. Again, there are 4 crew members currently living and working on the Orion spacecraft as part of the Artemis II mission. So Christina was speaking directly with the team here in Mission Control Houston, specifically the CAPCOM or capsule communicator, and that flight control position serves as the direct voice link between the crew and the ground.
Houston Integrity for cabin temps.
Hey, go ahead, Christina.
Yes, it is very cold in the cabin. Any chance you can make it warmer or reduce the cabin fan speed a bit more so the ventilation is not blowing as hard?
Yeah, Christina, understand. While y'all were asleep, we did turn one of our knobs that we have, and that was the rad loop set points. And we saw a very small increase in the temperature. And so we're going to take a look at some of these shell heaters, and we'll let you know when we start putting some of that in work, and we can see if that affects the temperature in a positive way.
Our next check with you is for your go, no-go confirmation.
And Christina, Houston is go for the burn.
Integrity copies.
Integrity Houston, the solar arrays are in position for the burn.
Integrity copies.
And this is Mission Control Houston. We are about 1 minute out from the perigee raise burn. That burn expected to last about a minute. The burn will adjust Orion's perigee, or the lowest point of its orbit, into the correct orbital geometry to set it up for its translator injection, or TLI burn. And that perigee raise burn is now underway. And there on your screen, you can see the 8 Pulsex engines on the Orion spacecraft. Now, this is a visualization of the Orion spacecraft, as we don't currently have live views from the spacecraft itself, but this uses the data and telemetry from the spacecraft. Again, this perigee raise burn expected to last about a minute. Currently, everything is proceeding as planned. And we do have confirmation that that burn is complete. It was a good burn.
We're tracking a good burn.
And we see the same, and with a bonus trim burn.
And there on your screen, you are seeing a live view of the Orion spacecraft from one of its solar array wing cameras, and you can also see another one of the solar array wings on the bottom right hand of your screen from the Orion spacecraft. Again, this live view comes following that perigee raise burn.
Support there. We really appreciate it. It's been a good first. Well, it's been 2 orbits of Earth, I guess, and this one's just got a 38,000 mile apogee. We're going to pick up in 261100 pre-sleep checklist, and then we're going to dim the cabin down and get some rest. Thanks for your support.
Yes, great PRB day. Excellent flight day 1, y'all. Get some good rest, and we'll be in touch in a couple hours.
You as well. Good night, Earth.
Good morning, Artemis II crew. While you're soaring beyond Earth, we're sending a little piece of home your way. Here are some messages from your NASA team to brighten your flight day.
From your friends in the R3 Flight Systems Branch, we are go for exercise.
Godspeed, Artemis II. Let's go fly from the Orion Engineering team.
Wishing you an excellent mission around the moon from the Huntsville Operations Support Center's Systems Engineering team. Go Artemis!
From the Marshall Space Flight Center Earth Science Branch to the crew of Artemis II.
We wish you success. Bring back some perspective.
We just wanted to wish you a safe trip to the moon from your JSD SWAT team.
From the Wallops Island Radar 5 crew, go Artemis, Godspeed.
Good luck from your Orion mission planning team.
IMAP team wishes you a safe journey.
Go Artemis II!
From all of us at NASA's Launch Services Program,
we're so proud to support the journey to the moon.
Go Artemis!
Houston Integrity, we are ready to go, and that was awesome. Thank you for all of those messages.
You are very welcome.
Good afternoon and welcome to the Artemis Flight Control Room here at NASA's Johnson Space Center in Houston, Texas. I'm NASA PAO Leah Cheshire Mustachio, your Orbit 1 commentator, ready to take you through a very busy day for the crew, namely with the translunar injection burn this afternoon. That is scheduled for 6:49 p.m. Central Time, expecting a 5-minute and 49-second burn on the OMS engine. On the left, the data visualization you're seeing is ARROW, the Artemis real-time orbit website. If you look closely, you can see we are now under 10,000 miles away from Earth. That will continue to decrease until we get to 115 statute miles above our home planet. That'll be the closest the crew is to the planet until they return for their splashdown on flight day 10.
Integrity. Houston has completed the poll for TLI. When the engine ignites, you embark on humanity's lunar homecoming arc and set the course to return Integrity and her crew safely home. Houston is go for TLI.
Integrity copies, and your Integrity crew is go for TLI. With this burn to the moon, we do not leave Earth, we choose it.
Mission control is go. The crew is go. You're getting a live view from Orion now of Earth. "10 seconds until translunar injection burns start.
Integrity. Good engine, good control.
We show the same. Feels great up here.
At MET, mission elapsed time of 1 day, 1 hour, and 14 minutes into the Artemis II mission. As Orion was flying 115 statute miles above Earth and 247,600 miles away from the moon, we have the start of the translunar injection burn that will send the crew around the moon, the first humans to do so in over 50 years. Velocity of the spacecraft ticking up, now over 23,900 miles per hour. 2 minutes into this 5-minute and 50 second burn. Continuing to get good calls here in Mission Control Houston from all flight controllers.
Integrity, we copy the enabled caution, no crew action.
Integrity copies.
Over 3 minutes now into the translunar injection burn. These live views coming from Orion as it looks back on Earth, leaving high Earth orbit and beginning its journey to the moon. We are now 230 miles above Earth, 246,500 miles away from the moon. We have 1 minute left in the translunar injection burn. Everything continuing to look good. We have less than 20 seconds left of this burn. This is the final major burn for the mission because this also serves as our deorbit burn.
Integrity looks like a good burn. We're confirming.
Integrity copies.
Confirmation from teams here on the ground to the Artemis II crew aboard Orion. We have translunar injection burn cutoff and early reports that it was a very good burn. Orion now 520 miles away from Earth. Just 5 minutes ago, we were only 115 miles above Earth's surface. That distance will continue to increase as we are now on a trajectory to fly around the moon for the first time in over 50 years. Live views from the Orion spacecraft as it looks back on Earth following completion of the translunar injection burn, the burn that commits us to flying around the moon. It also commits us to a return to our home planet on Flight Day 10 and a splashdown in the Pacific Ocean. But for now, these views of Earth as Orion starts its journey.
Houston Integrity, we just wanted to share a little bit of the sentiment up here as we came around the planet, and we're zooming over just 100 nautical miles above it if you got a moment.
Please, Jeremy, we are all ears.
Well, with that successful TLI, the crew's feeling pretty good up here on our way to the moon, and we just wanted to communicate to everyone around the planet who's worked to make Artemis possible that we firmly felt the power of your perseverance during every second of that burn. Humanity has once again shown what we are capable of, and it's your hopes for the future that carry us now on this journey around the moon.
Hugs there at the Capcom console from NASA astronaut and Capcom, or capsule communicator, Chris Birch, with Artemis II backup and Canadian Space Agency astronaut Jenny Gibbons. This is a live view from the Orion capsule looking back on Earth, our home planet. We are now 18,500 miles away from Earth. When we conducted that translunar injection burn coming up on about 2 hours ago, we were just 115 miles above our planet. Obviously, that has increased exponentially as we are now on the journey to the moon and back home. Currently, Orion is 223,000 miles away from the moon. This is Artemis Mission Control, now MET, or mission elapsed time, 1 day, 3 hours, and 10 minutes into the Artemis II mission, the first flight of humans around the moon in over 50 years. And we are going to the moon. After a successful translunar injection burn today, we are now over 19,500 miles away from Earth and growing closer to our lunar neighbor, now 222,000 miles away from the moon. The view on the left side of your screen is from Orion, a live view looking back at our home planet, that small dot. And down in the bottom right-hand screen, you can see Capcom Chris Birch wrapping up her Orbit 1 shift today, as well as Flight Director Jeff Radigan. They've been leading the teams throughout Orbit 1 and the translunar injection burn.
Integrity Houston, you ready for the event?
Houston Integrity, we are ready for the event.
ABC News, this is Mission Control Houston. Please call Integrity for a voice check.
Integrity, this is Gio Benitez at ABC News. How do you hear me?
Outstanding. We have you loud and clear. How about us?
I hear you loud and clear, and I truly cannot believe it. You are quite literally on the way to the moon right now and still speaking with us. Tell me, how do you feel? What's going through your mind? I mean, this must be so incredible because have you allowed the weight of the moment to really fit in here? Have you allowed that to happen?
Well, first and foremost, we all wanted to give a shout out to our families first because we are pretty far from Earth and we have not gotten to say hi to them yet. But there was a moment about an hour ago where Mission Control Houston reoriented our spacecraft as the sun was setting behind the Earth. And I don't know what we all expected to see in that moment, but you could see the entire globe from pole to pole. You could see Africa, Europe, and if you looked really close, you could see the northern lights. It was the most spectacular moment, and it paused all four of us in our tracks.
Yeah, well, you are making history. Reed Weissman, Christina Koch, Jeremy Hansen, Victor Glover. Congratulations to all of you. America, the world is with you. We are watching every moment of this journey, and we will cheer you when you get back and along the way. Thank you for joining us. Best of luck to you, and safe travels.
Good morning from Mission Control Houston. Inside the Artemis Flight Control Room here at the Johnson Space Center. We are at a mission elapsed time of 1 day and 17 hours of the Artemis II mission. The Orbit 3 team of flight controllers is currently on console as the crew has their last few hours of their sleep period. The Orion spacecraft is currently 94,000 miles and counting away from Earth and 165,000 miles away from the Moon. The Artemis II astronauts currently asleep aboard the Orion spacecraft named Integrity began their sleep shift at around a mission elapsed time of 1 day, 9 hours, and 30 minutes. Let's take a look back at what took place over the course of the last flight day. After their post-sleep period, during which they completed hygiene activities, standard cabin configurations, and ate breakfast, they had several conferences with the teams here in Mission Control to review their schedule for the day and the current vehicle status. The crew yesterday was focused on translunar injection, or the TLI burn. Christina was on tap to monitor that burn from inside the spacecraft, and the TLI burn was completed yesterday at 6:49 p.m. Central Time. The spacecraft ignited its main engine on the service module for 5 minutes and 49 seconds to get on a path to fly around the Moon and splash down off the Pacific. A fun fact, Orion's main engine provides up to 6,000 pounds of thrust, enough to accelerate a car from 0 to 60 miles per hour in 2.7 seconds. Following the TLI burn, the crew had some lunch and got into their space adaptation activities. Now, these space adaptation activities protects against space adaptation syndrome, or space motion sickness. Approximately 70% of astronauts traveling into space experience some level of this syndrome and the symptoms, and it's believed to be caused by conflicting sensory inputs from the vestibular or inner ear system and the eyes. The crew also completed a public affairs event, some daily exercise, a window inspection, and a private medical conference before beginning their pre-sleep and sleep period. The views you see coming in right now are from the Integrity spacecraft from one of the solar array wings. Just earlier over the course of the sleep period, the teams on the ground conducted a surveying exercise, or what we call a monitoring exercise. Essentially what they did was they took the solar array wings of Orion one at a time and moved them to face the crew module and service module of the spacecraft to inspect the vehicle for any damage post-launch. Similarly, the crew will conduct a similar activity following lunar flyby. The crescent that you see on your screen right now is actually of Earth. The sun is shining on Earth, and that is why it looks very, very bright, and that is actually daytime on Earth. The shadow that's cast on the other part of the Earth is where the rest of the world is in nighttime. So for now, we'll continue to provide periodic updates as the crew will soon be waking up. But for now, this is Mission Control Houston. Hello again from Mission Control Houston. We are coming to you live from the Artemis Flight Control Room here at the Johnson Space Center. We are currently at a mission elapsed time of 1 day, 17 hours, and 15 minutes. We are seeing some live views from Orion's Integrity spacecraft. These are live views from the solar array wings aboard the spacecraft, where we are seeing the sun cast its shadow on Orion, while in the distance we have Earth. There is the sun casting its light on Earth, where we see daytime, and where you see the darkness, that is where it is nighttime currently. Similar to the International Space Station, this kind of gives us a really great vantage point because the astronauts see 16 sunrises and sunsets every day 250 miles above the Earth. The Integrity spacecraft is currently 95,000 miles and counting away from Earth and 100,000 miles away from the Moon. Coming to you live, this is Mission Control Houston. This is Mission Control Houston in the Artemis Flight Control Room at the Johnson Space Center. We are at a mission elapsed time of 1 day, 17 hours, 44 minutes and counting. In just under 30 minutes from now, actually 24 minutes and counting, the crew will be waking up. Currently, the Integrity spacecraft is just over 97,000 miles away from Earth and 163,000 miles away from the Moon. The TLI, or Translunar Injection Burn, was completed yesterday at 6:49 p.m. Central. The burn lasted 5 minutes and 49 seconds to get the spacecraft on a path to fly around the Moon and splash down on Flight Day 10 off the coast of the Pacific Ocean. Right now, as we stand by for a crew wake period, there are a couple of data points I would like to share. What was that? First things first, you can see our data visualization tool on the right side of your screen. If at any time over the course of the Artemis II mission, if you go to nasa.gov/track-Artemis, you will be able to see where Orion is on its journey for the mission, how many miles it is away from Earth, and how many miles it is away from the Moon. On the left side of the screen, you have great views of the engines of the Orion spacecraft. These are the engines attached to the service module of the spacecraft. The views we're getting are from the solar array wings aboard Orion. Now, as mentioned, the live views on the left side of your screen are from the solar array wings on Orion. And we are seeing live views right now capturing the engines. You can see some venting happening in the images in front of you right now. Now, earlier today, while the crew slept, the ground control teams, or the flight controllers on the ground, completed a surveying of the Orion spacecraft. Essentially what that means is they shifted the solar array wings aboard the spacecraft to face the crew module and the service module to see if there was any damage sustained from launch. This is part of the standard operating procedures, and the ground teams will conduct another surveying activity after Orion flies around the Moon. As mentioned, we are at a mission elapsed time of 1 day, 17 hours, 49 minutes and counting, and the crew wake period is going to begin, or the crew will be waking up in just about 20 minutes from now. We will stand by to hear good words from the crew as they wake up to begin their flight day. For now, this is Mission Control Houston.
Houston Integrity on 1 for post-sleep.
Good morning, Victor. Go ahead.
It must just be our speed. It's read. Changing the octave of voice, I guess. Hey, just want to make sure you guys didn't juggle the schedule at all. That we are just starting our post-sleep now. We don't need to start working, but we do need to get some science done.
All right, Reed. Sorry about that, and sounds good.
And whenever you want to do some wake-up music, we can do some post-wake-up music.
This is Mission Control Houston in the Artemis Flight Control Room here at the Johnson Space Center. That was today's wake-up call for the Artemis II crew aboard the Integrity spacecraft. This marks the start of Flight Day 3 activities, and the song you heard was In a Daydream by the Freddie Jones Band to kick off their day. Activities today are focused on a CPR demonstration, space adaptation. We'll have a couple of public affairs events, as well as checkouts of medical devices, to name a few. With the crew having successfully completing TLI on Flight Day 2, they're on their way to the moon as we speak. Meanwhile, here, Artemis mission control teams in Houston monitored all systems, and the vehicle continues to perform well. For now, this is Mission Control Houston.
Welcome to the Artemis Flight Control Room, and welcome to Flight Day 3 of the Artemis II mission, a test mission and the first flight of humans on Orion. I'm NASA's Leah Cheshire Mustachio here in the Flight Control Room with the Orbit 1 team, now being led by Flight Director Jeff Radigan. It was a big day for the crew yesterday as the translunar injection burn was completed, committing Orion to fly around the moon on Flight Day 6 and return to Earth on Flight Day 10. Today we have another burn scheduled. That's the OTC-1 burn, Outbound Trajectory Correction 1. That's slated for 5:49 p.m. Central Time and would be an 8-second burn using the reaction control system thrusters. We've also been getting some imagery down from Orion, taken by the crew after the translunar injection burn. This photo showing the beautiful Earth outside the window of the spacecraft as the crew was flying away. And this next photo, a backlit Earth as the crew was departing from translunar injection. And if you look very, very closely up to the top of your screen, you can see the aurora borealis, and on the left in those clouds, a couple of lightning strikes. The crew continuing to get beautiful views from Orion, and we're even getting some views from the spacecraft as well. This is a live view from Orion and a camera on the tip of one of its solar arrays looking back at home sweet home and all of us on planet Earth. We are 1 day, 18 hours, and 47 minutes into the Artemis II mission. That's mission elapsed time, or MET. And don't forget, as we're showing you those beautiful new images, we really look forward to getting some new ones down periodically. You can follow at NASA and at NASA Artemis on X, Facebook, and Instagram as we all enjoy the imagery taken by the crew and coming down for all of us on Earth. The crew woke up at 12 p.m. Central Time today when they were flying approximately 99,848 miles from Earth, approximately 161,698 miles from the moon. You probably heard their wake-up song. That was In a Daydream by Freddie Jones Band. The crew is currently in their post-sleep time of the day. This is the time that they use to stow their sleeping bags as well as perform any hygiene activities, set up the cabin for their waking time, also gives them a chance to eat some breakfast. There are a lot of food options aboard for the crew. Of course, a very popular food item are tortillas. There are 58 in total on Orion. Some of the other breakfast items that the crew is enjoying today include vegetable quiche, scrambled eggs, couscous with nuts, peaches. They, of course, have their coffee, oatmeal, there's even a muffin being enjoyed today. During the post-sleep time frame, we don't expect to hear from the crew very much as they are taking their time to wake up, get the cabin set up for all of their events today. Aside from the outbound trajectory correction burn, the crew does have a little bit of off time scheduled. Of course, they are still on tap to be exercising 30 minutes a day using that flywheel device. This allows them to practice aerobic and resistive exercises and keep their bone and muscles strong while they are on the flight around the moon. There's additionally a CPR demonstration today. The crew will use the medical emergency procedures to simulate methods of how to treat an airway obstruction as if they were in space. This is a test flight, so we're taking every opportunity to test anything possible while the crew is on their 10-day mission. They also have some time scheduled today for lunar flyby cabin configuration. Now, we're not expecting lunar flyby until flight day 6. However, they will need to configure the cabin properly to allow them to most easily access the windows and conduct their observation opportunities. This cabin configuration will include getting out any sleeping bags or window shades to keep the light from reflecting from the cabin onto the windows that they're using to photograph. They'll practice handing off the camera between their flyby pairs and determine their ideal setup and positioning preferences for each crew member during those flyby operations. We also have a Deep Space Network emergency communications development flight test objective timeline for today. As we've discussed, the crew is able to communicate through the Deep Space Network, or DSN. This is the first crew in over 50 years to be using the Deep Space Network to communicate back to Earth. They were on TDRS, or Tracking Data Relay Satellite Systems, for a brief time yesterday afternoon as they were near our home planet. But the farther they get away, the more reliant we are on the Deep Space Network. This Emergency Communications Development Flight Test Objective, or DFTO, has the crew perform a checkout of the emergency communications system while connected to the Deep Space Network. Of course, there will not be an active emergency for the communication system at that time. This is giving us an opportunity to check out that system. The crew is also slated to conduct some National Geographic filming today. National Geographic was selected through a competitive selection process to help tell the story of Artemis II. The crew has a shot list provided by National Geographic, and they take some time each day to document what it's like to live and work on Orion. Later today, we also have 2 crew members timelined to activate and check out some of the medical diagnostic devices that we are flying on Orion. That includes the blood pressure monitor, thermometer, stethoscope, and otoscope. This is Artemis Mission Control. Now 1 day, 19 hours, 3 minutes mission elapsed time. You're looking at a live view from the Orion spacecraft back at all of us on Earth. This camera is mounted on one of Orion's 4 solar array wings. These are some of the same cameras that we'll be using when we fly by the moon on flight day 6 to give us views of the lunar surface. Now that we're at the start of another flight day, our crew is in their post-sleep period. Let's get a look at who is flying aboard Orion. Artemis II Commander Reed Wiseman is a Baltimore native who has flown in space previously as a flight engineer for Expedition 41 aboard the International Space Station. That was from May through November 2014, a total 165-day mission during which he and his crewmates completed over 300 science experiments. They also set a milestone for station science by completing a record 82 research hours in a single week. Wiseman also served as chief of NASA's astronaut office from December 2020 to November 22, and back here on Earth has 2 daughters. Pilot of Artemis II is NASA's Victor Glover, selected as an astronaut in 2013. At the time, he was serving as a legislative fellow in the United States Senate, and his first trip to space was in November 2020 when he launched as the pilot of NASA's SpaceX Crew 1 mission. Victor is a U.S. Navy captain and naval aviator who served as a test pilot, racking up more than 3,500 hours in more than 40 different aircraft, and he and his wife have 4 children. Mission specialist Christina Cook is a native of Grand Rapids, Michigan, selected the same class as Victor Glover in 2013 to join the astronaut corps. She served as a flight engineer on the space station from March 2019 to February 2020, during which she set a record for the longest single space flight by a woman, totaling at 328 consecutive days in space. She also participated in the first ever all-female spacewalk, and before becoming an astronaut, she helped build space science instruments and led scientific field work. Her hobbies include surfing, rock climbing, community service, yoga, travel, and photography, and she is certainly getting a chance to practice that photography on this mission. First-time flyer and Canadian Space Agency astronaut Jeremy Hansen is flying to the moon as a mission specialist on the Artemis II mission. The London, Ontario native was selected as an astronaut in 2009 and since then has worked as a Capcom at NASA's Mission Control Center here in Houston. Capcom stands for Capsule Communicator. That's the single voice you hear communicating with the astronauts in space. He also participated in training exercises like living on the ocean floor off the coast of Florida for 7 days, all to simulate deep space exploration. And in 2017, he became the first Canadian to lead a NASA astronaut class. Jeremy and his wife have 3 children. That's who's flying aboard Orion. Again, this camera coming from the spacecraft. On the left side of your screen, you can see the European service module, just the bottom portion of that, and the OMS engine, the Orbital Maneuvering System engine. That engine alone provides 6,000 pounds of thrust, and that's what we used yesterday during the 5-minute and 50-second burn, the translunar injection burn that committed the astronauts to their lunar trajectory. They will fly around the moon on flight day 6 and splash down in the Pacific Ocean on flight day 10. That OMS burn is not intended to be used again. For all of these orbital trajectory correction burns, again, targeting the first one of those today at 5:49 p.m. Central Time, exactly 23 hours after the translunar injection burn, the spacecraft will use the reaction control system thrusters. These allow for much smaller, finer maneuvers, and that will only be an 8-second burn, helping the crew maintain their trajectory around the moon. where you see a live view of Orion on the left side of your screen. On the right side, we have a visualization that helps track where the spacecraft is. This is called ARROW, Artemis Real-Time Orbit website, and you can visit this anytime for yourself at nasa.gov/trackartemis. As you can see, the spacecraft is now over 100,000 miles from our home planet and inching closer to the moon, 159,728 miles away. This is Artemis Mission Control at Johnson Space Center in Houston, Texas. Again, on your screen, getting a live view from Orion, looking back at all of us here on Earth. Now, 1 day, 19 hours, coming up on 18 minutes into the Artemis II mission. In about 45 minutes, actually just a little less than an hour, the crew will have their daily planning conference where we hear them discuss the day with the flight control team here on the ground. Additionally, some of the team members or the crew members will take their pulse ox using the pulse oximeter measurement. And some of the crew members will even get to conduct their private family conferences. The crew has not gotten to speak with their families directly just yet, and so this will be the first time during the mission that they'll be able to call down with video and speak to their friends and family. Of course, as those conferences are private, we won't be able to air those, but we are excited for the crew. This is Artemis Mission Control at Johnson Space Center in Houston, Texas. We are now exactly 3 days and 5 hours until the beginning of lunar flyby. Of course, the view on your screen from Orion looking back on Earth. Mission elapsed time of 1 day and 19 hours, 27 minutes. Here in Mission Control Houston, and specifically the Artemis Flight Control Room, Jeff Radigan is the lead flight director for the Orbit 1 shift, which is on console right now. Every flight controller monitors a different system aboard Orion, and they are beginning to prepare for the daily planning conference that they will hold with the crew. We're expecting that daily planning conference to come up in about 40 minutes. During that time, teams on the ground will report the status of the vehicle and any activities the crew needs to be aware of as they move throughout their day. You're looking live at a view from Orion on the Artemis II mission, now over 104,000 miles away from Earth, 158,440 miles away from the moon. We are 1 day, 19 hours, and 42 minutes into this first flight, a test flight with the crew. And you're getting a view right now from a camera on the tip of the solar array wing, one of 4 solar array wings aboard the spacecraft. These cameras allow us to take surveys of the exterior of the spacecraft, but they also give us views like this. You are looking at a live image of the moon. Again, the spacecraft now 158,420 miles away. This is Artemis Mission Control here at Johnson Space Center in Houston, Texas. And as we enjoy this view from outside of Orion looking toward the moon, inside Orion, our 4 crew members are still in their post-sleep period. Again, they woke up at 12 p.m. Central Time today, and since then have been configuring their cabin for the day's activities, as well as conducting hygiene and preparing for the rest of their day. We won't hear from them for probably another 30 minutes when we conduct the daily planning conference. Here on the Orbit 1 shift, the flight director, Jeff Radigan, gathered inputs from all of the flight controllers on the systems aboard Orion and anything that they needed to ask or share with the crew for today.
Houston Integrity stowage question.
Good morning, Integrity. We're ready to take your question.
Good afternoon to you, Chris. I think it's afternoon there. We were wondering if we could get some help finding the electric shaver.
That's right, Christina. I think we're in afternoon here in Houston time. I'm keeping Orion time myself. And we will get a location for you to look here shortly.
Thank you. Asking for a friend.
This is Artemis Mission Control in Houston, Texas. Some of our first calls from the day coming down from the crew. Since they have woken up, they're still in their post-sleep period. Again, they're able to conduct hygiene tasks at this time. And so that was NASA astronaut and mission specialist Christina Cook calling down to ask about the location of the electric shaver. Now, all of the items that are in Orion are carefully tracked and stowed, so that way when a crew member calls down looking for any piece of equipment, flight controllers here can look up exactly where they are able to locate it within the spacecraft. So while teams on the ground are checking, they will be searching their systems and relay back up to the crew a very specific location that they can expect to find that shaver.
Integrity, Houston, with a possible Razor location.
Good morning, Chris. We are ready. Go ahead.
Good morning, Christina's friend. You may look for the Razor in locker D, bag 6. We'll have a purple label. This is Reed's suitcase, and we expect it to be located in the crew hygiene kit.
Okay, we copy that. Thank you, locker D, bag 6, and we will find you. Appreciate the help.
This is Artemis Mission Control. That call from Capcom and NASA astronaut Chris Birch being received by NASA astronaut and pilot of the Artemis II mission, Victor Glover. If you recall, recently NASA's Christina Cook called down to inquire about where the crew might find an electric razor. And if you listened closely, you heard the team on the ground is able to provide the exact location and locker where that would be stowed. The astronauts are still in their post-sleep period.
Houston Integrity, we only have it temporarily positioned, but would you like to come on board for DPC here in a few?
Good morning. Yes, absolutely. We would love that.
In the next 10 minutes, we will have the daily planning conference where teams on the ground will relay any details the astronauts need to know about the Orion spacecraft ahead of their flight day 3. This view coming from the spacecraft looking toward the moon. At this time, Orion is 157,560 miles away from the moon. And during the daily planning conference, we are looking forward to potentially seeing the crew living and working aboard the spacecraft.
Integrity crew,
Hello, Ted.
we
This
are
is
now
Beth
on board.
here at the
Great to
NASA
see you
Johnson
guys.
Space Center. How do you hear me? Fantastic. Yes, this is the main
Copy those
feed and
thumbs.
the only
Great
feed
to
that
see
will
you
be
guys.
providing
Good
audio
morning.
to the conference. We usually do, but today we're in live mission coverage. So if you have music that you would like to play, that might be a good thing today.
You're getting a live look inside the Orion capsule at our 4 Artemis II crew members, now 106,000 miles away from Earth. We are standing by for their daily planning conference, where teams on the ground will be relaying up information for the crew as they start flight day 3. From left to right, we have NASA astronaut Christina Koch, Reed Wiseman, Victor Glover, and on the far right, Canadian Space Agency astronaut Jeremy Hansen. As we get a look inside Orion, a little scene setter for you. The interior habitable volume is 330 cubic feet, so that's about the size of 2 minivans. This is 60% more cubic volume than the astronauts had during the Apollo missions.
Integrity, small request. If you could tilt the camera down slightly towards the lockers. We have a great view of Christina and some of the boxes up above. Thanks.
Yeah, no problem, Chris. I did not mount it. I just kind of friction fit it, and I'll get a better spot for it later today, and we'll get a more permanent mount going.
Sounds like a great plan. Thanks.
we're ready for morning DPC.
Good morning, Integrity. We are so happy to be on board with you today. You guys look great. That cabin config looks amazing. We would love to be on board as much as possible today. We'll stop streaming for the family conferences, but would request to come back on board afterwards to share your mission with the world. I have quite a number of topics for you today. I'll start with trajectory. We are actually going to continue evaluating the need for OTC-1 based on the small magnitude of the burn. We'll have an update for you later. A couple of vehicle statuses. In order to address what we saw last night with the small increase in ox tank pressure accompanied by a small decrease in the ox helium tank pressure, we did to do some troubleshooting, we closed the valve ox helium ISO 1. You can see this on the top left of your prop ohms plus X page. We're continuing to look at that. Don't have a full story for you yet.
Okay, I'm not at the displays right now, but I will take a look at that soon.
Great. And then just a reminder for the memorized response for the manifold run box, plus X manifold run box fail message we saw last night. Memorized response would be DAP free first, then secure SM prop.
Yeah, 100%. And I elected not to take that action last night because it was coming in and out of alarm. But if you tell us you want us to take action immediately, let us know.
Copy, Reed, will do. All right, continuing on. We're planning to manage our wastewater tank to a lower quantity. So we'll expect some real-time coordination. Basically, we'll be adding some wastewater dumps that are not captured on the timeline. So we'll let you know when those are going to occur. And then regarding those wastewater dumps, when we perform those or have performed those in the past, do you guys hear any sounds in the cabin? We want to know if we need to deconflict those activities from other activities on your timeline.
No sounds, but it is certainly visible.
Copy that. Thanks. All right, regarding the PWD delayed flow termination, we wanted to let you know that this is actually behavior we've seen on the ground, but we'll still take any data that you gather from the flight. And there are some prompts in the mission summary for that. We can turn to that at the end of this update.
Okay, sounds good. We did figure it was just inherent in the design of the system and the tubing, and it's an efficiency hit and a bit of a cleanliness hit for us, but primarily an efficiency hit.
Copy, good report. All right, moving on to PCDs. This is just a reminder that PCD 3 will need to be hardlined for the family conference. And then sometime today, at your convenience, we need to power cycle each PCD in turn to clear out any hard drive errors.
Copy that. We'll get on that after DPC.
Great. And then finally, some feedback on science collection. This is the first time you performed saliva collections. Any feedback or concerns you want to pass along?
None that we can't do in debrief after the mission. It was fine.
Okay, copy all. Now we are ready to take any answers you have from the mission summary and answer your questions.
Okay, from the mission summary, question number 1, we are good with PCD 3 for now. Question number 2, we are good with cabin temperature overnight. We might make an adjustment in a day or two, but for now we really appreciate all that help. It's going well. For question number 3, I think we just covered that. It is primary and secondary. For question number 4, we put a lot of thought into that, and we definitely agreed that your method was the best. Ike did a good job putting some towels around the dispenser, and overall, he and Christina had a very good cadence going of doing the fill. So that was about the ideal way to do it. It was not very messy once Ike got it going. And then for question number 5, we would like to just have Christina call you later when she's got some gray space.
All right, copy out. Good plan.
And one go back on number 3 for the PWD. I think we're all synced up, but that has been since day one. That didn't just start happening. It's just due to the design of the tubing.
Yep, copy that clarification.
All right, it was really great to wake up this morning and look out the window and see the full moon off the front of the vehicle. There's no doubt where we are heading right now, and really appreciate all the work down there. It was also really awesome. Thank all the FIDOs. I can't believe that actually all worked. And when I saw that OTC-1 was like a 0.8 meter per second burn this morning on targeting, I thought we might skip it, and that is pretty impressive. All right, signing off.
Thanks, and copy all integrity.
This is Artemis Mission Control. That was Capcom Chris Birch here in Houston, Texas. She is also a NASA astronaut, speaking with the crew living and working aboard Orion for the Artemis II mission. We are now 1 day, 20 hours, and 17 minutes mission elapsed time for Artemis II. That was the conclusion of the daily planning conference. However, if you listen to the start of that conference, you did hear the relay to the crew that we hope to have the cameras on as much as possible throughout this flight day to allow us to share their journey with the world. So we intend to be able to share the crew with you as much as we possibly can. They are going to move into some of their other tasks today. Again, you heard them discussing the OTC-1 burn, that's orbital trajectory correction burn, or sorry, outbound trajectory correction burn. And Christina Cook taking the camera to show us a wastewater dump. So you heard Commander Reed Wiseman reporting that they don't necessarily hear those wastewater dumps, but that they do see them. So you're getting a live look outside the windows of the Orion spacecraft as they conduct that wastewater dump.
Integrity, we copy that successful wastewater dump.
At this time, the Orion spacecraft is over 106,000 miles away from Earth, 156,800 miles away from the moon. We are moving along with the crew's day. We intend to see them quite a bit, but we are going to not have views for a very short time as they are going to be speaking with their families. These are timelined opportunities to speak with family members down on the ground, so we do turn off the cameras for their privacy at that time. As we were discussing the outbound trajectory correction 1 burn, it was timelined for 5:49 p.m. Central Time, exactly 23 hours after yesterday's translunar injection burn.
Integrity, we are all configured for the family conference. You are go to deroute the live stream video, and we'll see you after the conference.
As we mentioned, the crew is getting into their private family conferences, so we are not going to having views inside the cabin at this time, but a pretty good view from one of those solar array wings looking at the moon, again, about 156,800 miles away from the spacecraft. Lunar Flyby Day will be flight day 6, and our live continuous coverage will be showing you all the views we possibly can of the lunar surface and the crew as they perform that work. But again, that outbound trajectory correction 1 burn, it is exactly as it sounds. It's to help the crew maintain course for their flight around the moon, and it is a follow-up to the translunar injection burn that occurred yesterday. That would only be an 8-second burn today, so as you heard Capcom Chris Birch call to the crew, it may not even be necessary because our trajectory is so spot on. This is Artemis Mission Control. We are getting live views from the Orion Spacecraft looking at the moon, the destination of the 4 astronauts living and working aboard the spacecraft. Again, the crew woke up at about 12 p.m. Central Time today. They entered their post-sleep period, conducted their cabin configurations and hygiene before moving into the daily planning conference, which just wrapped up about 10 minutes ago. We do intend to see great views of the crew throughout the day while working aboard Orion. However, one of the crew members is enjoying a daily family conference right now. So while they are speaking with their family, we do appreciate the opportunity to give them some privacy, and you are getting this great view of the moon, currently 156,440 miles away.
Houston Integrity question on grab sample container.
Christina, ready for your question.
Thank you. Do you need me to use a specific serial number or just either?
Either is fine. Thanks for checking.
Copy, thank you.
This is Artemis Mission Control. I am NASA PAO Leah Cheshire, joined here by Canadian Space Agency astronaut, Artemis II backup crew member, and a Capcom, Jenny Givens. Thanks for joining us.
My pleasure. Thanks for having me.
So I would love to know a little bit about your experience as a Canadian Space Agency astronaut. What has that journey been like for you?
It has been overwhelmingly positive. I mean, I feel very lucky to be in the role that I'm in, but it's just really the honor of my life to work missions like this. Like seeing one of my very dear Canadian colleagues and my other dear friends in space has been pretty phenomenal. So the past few days have been exceptional, but also just to be embedded here at NASA as a Canadian astronaut. We have an excellent partnership and we're boots on the ground here at NASA. And I see every day really the results of what you get when you have a shared mission and you work together, and we just have a really bright future. I feel very positive about being here.
I agree. It's very exciting. So you've been training as an Artemis II backup crew member alongside the crew very closely. Can you tell us what that's been like?
Yeah, absolutely. It's been a long road. So backup crew members, we're kind of in an interesting spot because we do all of the crew training, and it's a very developmental mission. It's very nascent, so we're still learning. We do a lot of developmental work and contribution. Right there alongside with the crew, there were 6 of us assigned to this mission, and 4 of us are up there now. So that's a joy to see. And as we approach the mission, my work really transitioned to support. So what can I do to get these guys safely off the ground? Andre and I both worked as astronaut support people. You saw Dre strap our crew into the capsule, which was very cool. And now I have the pleasure of sitting in the Capcom console. So supporting them with my training and knowing what they know. And I have a lot of joy every day I see them up there. So it's been great.
Fantastic. And you mentioned the Capcom console, so you are going to be our Capcom, our capsule communicator during lunar flyby. Aside from participating in sims, the simulations alongside where the crew is in the simulator, we're here in Mission Control Houston. How else have you been preparing for that monumental day?
I have had the pleasure of working very, very closely with our science console. So for Flyby, we'll have Kelsey Young in there. She is a phenomenal geologist, along with many of our other science support people, and they really have been training us about how to observe the moon in a way that's accurate and helpful, but also just beautiful. Like, imagine what these crew are going to see. I just can't wait for that shift, like talking to them as they approach the flyby, fly so far away from our Earth, look back and observe both the moon and observe our own Earth. It's just an honor to share that milestone with them. So a lot of crew training, a lot of work with the geologists, which also has been a joy, and my own preparations about how I just want to share this with the world. I want people to be really proud when they see our crew do this and see themselves in the words that they share.
We are so excited. I am counting down the hours. In fact, we are 3 days, 3 hours, and 49 minutes into the beginning of lunar flyby. And so talking about your Capcom experience, you were the lead Capcom for Expedition 63 aboard the International Space Station. So how did that help prepare you for this, and what are some similarities and differences?
Absolutely. Well, flying the ISS is obviously, you have a lot of the same roles here in Mission Control, but it's very different. This is a very small ship. We have our crew totally plugged into what's happening all the time, a very defined mission and a much shorter mission. So I would say it's much busier. But our ISS training has really equipped us well. So like the relationships that I formed on that increment, I am seeing a lot of those flight controllers in the room with me for TLI. We had the same INCO or like comms controller here, that was a joy. So really relying on the relationships that I formed earlier, that's just paid dividends and has been so positive to see those people shine in their roles. And then you just learn how to talk to your friends in space, and what a cool thing. What a cool thing we get to do. So really we laid the groundwork in a lot of our ISS work for this mission.
Yeah, truly an honor. And so before we wrap up, I know you do need to get back to the Capcom console. Do you have any parting words? Anyone you'd like to give a shout out to here?
Yeah, absolutely. I have to give a shout out to the families. So seeing the resilience that the families of this crew and my own family have shown as we work to go further than we've ever gone before. You guys are amazing and the unsung heroes of this mission. And I just had the pleasure of being with a few family members during the launch, and it was beautiful. We had a few words, many smiles, many tears, and it was just a joy to see these people experience their crew members achieve their dream. I will truly remember it forever, and I am so proud of you.
That's beautiful. Thank you, Jenny. Thank you for bringing this mission to the world as well. And we are counting down the hours to lunar flyby, but for today, focused on Flight Day 3 and all that the crew has to bring to us. So thank you again.
I love it. Let's do it. Thank you.
Houston Integrity, we had a great PFC on board, and we are ready for the bird conference.
Copy, Integrity. Great timing. We just finished our discussion about OTC-1. And with such a low magnitude OTC-1 and with a low magnitude OTC-2 with a no perform of OTC-1, we are not going to perform OTC-1. Ground is going to proceed through the OpNav calibrations, and then ground will cancel the burn at MET 1 day, 21 hours, 50 minutes after the OpNav pass. How copy?
We copy snow day, and understand the time is about an hour and 10 minutes from now when you're going to cancel. That was something like 21:50.
That's it, firm.
Great. Would you like us to follow along or do any steps before then?
No crew action or monitoring required today.
Okay, we will take the time to get this cabin looking good, and I think you can come back on board in the HHP camera.
Sounds great, and Christina, thank you. We'll take you up on it, and we'll be coming on board.
This is Artemis Mission Control, 1 day, 20 hours, and 43 minutes mission elapsed time into the first flight of humans aboard the Orion Spacecraft, NASA's Artemis II mission. As you heard that call from the ground to the crew living and working aboard Orion, we will not be executing the outbound trajectory correction burn today. The burn was so small and our trajectory is so precise after the translunar injection burn yesterday at 6:49 p.m. Central Time, there is simply not a need for that OTC-1 burn today. We were targeting 5:49 p.m. Central this afternoon for that burn, but as you heard from the ground, they will be the ones sending that cancellation, and therefore the crew will not need to take an action, and as Christina Cook calls it, have a snow day. This is a live view outside the Orion spacecraft looking at the moon, 155,860 miles away. We are about 10 minutes away from a mission briefing here at Johnson Space Center in Houston, not with the astronauts, but instead with NASA leadership. If you are watching on the NASA
Integrity timeline.
Go ahead.
Hey, Chris. Reed is complete with his EMER mask deploy for the spare mask. And we have a question about the PCD-4 when convenient. I'd also be ready to do the trash mini conference when convenient. And before we act on either of those, Reed has something for you regarding his PWD activity.
Copy all. We're ready.
For the PWD video, do you want that on an iPhone, on an HHP camera, or just whatever? Are you going to download that later? You're not looking to download it today?
Reed, we are not planning to download that video during the mission, so dealer's choice.
Okay, awesome. Thank you.
That's Commander Reed Wiseman calling down about a timelined activity for the crew today. The PWD stands for Portable Water Dispenser. And the potable water dispenser is what the crew uses to fill drink and food bags. So the request from the ground and timelined on the astronaut schedule for today is to take a video using that potable water dispenser while filling up a drink bag, filling up a rehydratable food bag. Again, this is a test flight, and so we are experiencing everything for the first time with humans living aboard Orion. So this video will be reviewed by the teams on the ground after the mission. Again, we are about 7 minutes away from a news conference here at Johnson Space Center in Houston, Texas. And if you're watching this live stream on NASA's YouTube, you won't need to go anywhere to tune into that news conference. However, if you want to continue watching this mission coverage, we do have a second stream of views available on NASA's YouTube. So you can just back out of this stream, click on that other one, and we will continue providing views of the crew and commentary here in Artemis Mission Control.
Integrity, Houston, just let us know, Christina, when you are ready for PCD-4 talk and the mini trash conference. We'll just be here standing by.
And I'm ready, Chris. Go ahead.
All right, Christina, this might be it.
And Houston Integrity, let me know if you'd like me to go ahead and start with what I've got based on the question from the flight message, flight day message. I can just get started, and then we can generate some back and forth after that.
Yeah, Christina, we will take what you got first.
All right, thanks. Well, first of all, as you might imagine, there's kind of an inrush of trash when we first get up here as we're deploying everything. So we did generate quite a bit of trash in the first 30 hours of the flight. We've been managing that by kind of finding hidey holes for it and putting some of it back into empty locations. The majority of it is in official Orion trash bags. However, some of the packing material was just packed back into some of the Ziplocs that were part of the unpackaging process. So one question we have is, our understanding is that we were basically free to put trash into open locations in CTBs as it was generated, and that the hope or priority would be locations in the D and E lockers. We haven't really opened up much space in CTBs there, like there aren't any fully empty CTBs to start packing with trash. So our ask is, do you have a recommendation for where we should start prioritizing putting the Orion trash bags as we generate them, and potentially a request to consolidate some stowage so that we can designate a CTB that's all for trash?
All right, Christina, we were just talking a little bit here. We do have a location, a desired location for this trash, and recognize I'm directing you towards a place we said we haven't deployed much already, but we have some items for you to take out. The location will be Locker D, Bag 1, yellow label. We'll pull out a couple of items. I'll get those to you shortly, but that should alleviate enough space to put about 3 trash bags in that location.
That sounds great, and that will cover the loose trash that we have right now on board. We have about 4 bags altogether, and we found a home for one of them.
Christina, that sounds good.
And I have a couple comments about the uphill garment trash that we have when you're ready.
Yeah, Christina, sounds good. We'll take that uphill garment trash info and also would be looking for the location of that 4th trash bag just so we know where to restow things.
Okay, perfect. The uphill garments, so the comfort garments, we put into the Flight Day 1 clothing bags. So we basically just swapped the locations as we changed into our Flight Day 1 clothing, and we restowed it into the locker that they came out of. Additionally, into that locker, we have our mag trash. It is currently double Ziploc bagged, but it is not in an Orion trash bag. And we'd prefer to keep it that way because we have all 4 single Ziplocked mags with their odor absorption sheets in one big Ziploc, so the 4 of them together would not fit in an Orion trash bag.
Christina, we copy that location and that request. We're going to assess and let you know if anything needs to change.
Awesome, thanks. I don't know off the top of my head the location of the 4th trash bag, but as I'm putting away the others, I'll come across it and I'll update you with that.
Copy, sounds good.
Another question when you're ready.
Go.
For all of the packing material, this would include clamshells, bubble wrap, Ziplocs, and regular Ziplocs. We basically feel like our training was that we didn't necessarily need to keep the regular Ziplocs, but that it would be good to keep clamshells or any designated unique Ziplocs that are padded for restow. So wanted to double check this understanding and get any guidance if we should do it differently. But again, what we're doing is keeping clamshells, keeping any unique bubble wrap Ziplocs. We're keeping them with
Apologies to interrupt the crew aboard the Orion spacecraft, but if you are watching on NASA's YouTube, stay tuned. We are expecting our news conference to begin momentarily.
The Artemis II mission is a test mission of the Orion space capsule.
Artemis II will be the first time we put humans on this rocket.
We're going back to the moon because it's the next step in our journey to Mars.
We were always going to the moon.
Pushing ourselves to explore is just core to who we are. That's a part of being a human.
And liftoff. We shall return.
Continuing to test out every bit of Orion.
Coming back to Earth, 7 miles a second.
When humanity sets big goals, we can bring together genius from around the world.
You have the best people on planet Earth putting this vehicle together. That's what's up.
To innovate for the benefit of humanity and to inspire the world through discovery.
And here we go.
Good afternoon and welcome to NASA's Johnson Space Center for our Artemis mission status update. We are joined today by Lakeisha Hawkins, Deputy Director for NASA's Artemis program, Judd Freeling, Artemis II Flight Director, and Howard Hugh, Orion Program Manager. We'll be taking questions from here in the room and through our phone bridge, but before we kick that off, we will go ahead and start with opening remarks. Lakeisha, go ahead.
Thank you. And welcome to the third day of Artemis II. We appreciate the continued interest from around the world in the mission and in our crew. Since yesterday's translunar injection burn to send the crew around the moon, the mission continues to perform well overall, and the crew is in great spirits. Currently, the crew is more than 100,000 miles from the Earth and about 150,000 miles to go away from the moon. You know, Victor said that we call amazing things that humans do moonshots for a reason. And indeed, this is literally and symbolically our moonshot that we're in the middle of. You know, it's great to get some very clear video and images of the crew yesterday, and the crew configured their cameras aboard Integrity, and we have some of the latest images to share with you. If you could call up the first image. This first one we got to the ground shows the unique vantage point of the crew as they look back at the Earth. It shows a backlit Earth revealing auroras as the crew heads towards the moon. It was taken by Reed Wiseman out of an Orion window, and it features 2 auroras, top right and left and bottom left, and zodiacal light, which is at the bottom right. It's visible as the Earth eclipses to sun. You know, it's great to think that with the exception of our 4 friends, all of us are represented in this image. You could call up the next image, please. This one shows Earth, as you can see, the Terminator line. And Reed also took this photo after translunar injection burn yesterday. What an amazing shot that he shared with us here. So we continue to learn all about our spacecraft as we operated in deep space with crew for the first time. And it's important to remind ourselves of that as we learn a little bit more day by day. So Judd, if you could talk a little bit more about details.
All right, thanks, Lakeisha. Let's see, so when we last left yesterday after the translunar injection, the crew did some press conferences with media. They did a detailed inspection of their windows. They also had planned medical conferences, and while they were sleeping, the ground did some looking at the crew module and service module, a survey to just see how the vehicle is doing from an external view. We also continued some OpComm passes, so the optical comm antenna that we have on board to downlink high-rate images. We were able to do that overnight. This morning when the crew woke up, they had their normal planning conferences, and then they were able to do their family conferences, so they were to talk to their family. And they also did another noise characterization of how loud the toilet was. So they performed that. We had planned today a trajectory correction burn for OTC-1 is what it's called, orbital trajectory correction. The systems are doing so well, navigation and propulsion systems together, that was not needed, so we'll roll that in to the next planned trajectory correction tomorrow. And I'll hand it over to Howard to talk any specifics on the Orion systems.
Thanks, Judd. Great to be here again. Let's see, our subsystems continue to perform very well. Everything is nominal and as expected, so really good to report that today to you. As Judd said, we did the translunar injection yesterday, and we get a chance to look at the data, and the propellant usage was within 5% of our predicted usage limits. So it was really good to see it go so well, and the performance for that 5 minutes, 50 seconds was outstanding. Let's see, across other subsystems, no issues relative to solar array and power generation. The air revitalization system is doing very well. We are scrubbing CO2 at very good, healthy levels. We're keeping the humidity in the right range. And the crew, obviously you've seen, looks like they're enjoying their time in the cabin. And across various other subsystems, like I said earlier, we're performing as expected or better in some cases. Now we are working through one issue with the SM prop in terms of pressurization. So we have helium that pressurizes the propellant tanks, basically pushes out the oxidizer and the fuel in order to make some of the major burns. And so we had to shut off, isolate one of the branches. We have redundant branches in the system, no emission impacts. This is why we build redundancy in the system. But we're evaluating that, we're looking at that. That's maybe something you heard on the loop relative to what we need to do to isolate this particular branch. The second branch is ready to go. And when I say no mission impacts, we're able to perform the rest of the burns across the mission without doing any regulation, what we call blowdown mode. In other words, there's enough helium pressure in the tanks itself that we can push out the oxidizer and the fuel without needing to regulate or require more helium from the helium tanks. So overall, our redundant capabilities are providing the coverage that we need as we move across the mission. Let's see. Yesterday also, I think somebody asked this question, but the crew was able to exercise. And I said yesterday, I think we talked a little about any performance implications on the guidance navigation control system and talked to our experts, and there were no implications on that. So performed as expected in terms of what we thought the forces that would get imparted when the crew does the flywheel, that we addressed that very clearly through our design. And I'm happy to see that performance held up very well. Let's see, I have, I guess, my own couple images that Lakeisha showed you some, and I have a couple of my favorites. So the first one is just awesome to see from our spaceship. Out the window, our beautiful home planet, the Earth. I believe Reed took this picture, and it just brings a lot of great emotion to me, and to see that picture being taken. I know there's a lot of other pictures that we're going to see that are just going to be outstanding and fantastic to be able to enjoy. And then the second one, I had not seen the crew in a while. I've obviously heard them, but to see them in the interview, I do believe that I think Jeremy is too comfortable that way. I'm not sure he's working that hard, so I'm going to have to check to see if he's doing anything more than just laying there on the side here. But great to see the crew, great to see their smiling faces, and hear them talk about their experience already so far. And I can't wait to talk to them when they land home back Earth. And I think that's it for me today.
All right, thank you. We will go ahead and start our Q&A session. If you're in the room, please raise your hand if you have any questions. And if you're on our phone bridge, please press *1. We'll start right here with Mark in the back.
Hey, hello everyone. Good to see you all again. Mark Strassman with CBS. John, I want to ask you a question, if it's okay. You know, there are millions of Americans, unlike people in this room, who are just catching up with the fact that there's a moonshot going on this week. Who knew? So I want to just sort of scoot ahead to Monday's milestone, the lunar flyby. Why does it matter? What do you hope to get out of it?
So it matters because, you know, the whole point is to go back to the moon. The whole point of this mission is a campaign to get back to the moon. And the being able to see with human eyes the lunar surface is a huge milestone, right? And that just articulates the point, you know, that we're going back to the moon, we're going to stay there, right? And so this is the first step towards that. We'll obviously build upon that. We'll get eyes on the moon, kind of map it out, and then continue to go back and in force.
Yeah, I think maybe I'll go next. I think for us, I'll just touch or follow on what Judd said, which is the building blocks. You know, we're building a transportation system. And to have a reliable and robust transportation system, you need to test flight the transportation system. And I think that's really important. We've demonstrated on Artemis I with uncrewed capability. We've added a very important aspect of it, which is the crewed capability. And that crewed capability enables us to really understand how, when we have people in the cabin, how the systems operate and adjustments we need to make. You hear a lot of these kinds of things that over the loop, you know, minor adjustments we need to do. Certainly engineering expertise and the design we put in has a certain understanding, but until you put people in the mix and you operate it and really understand what you need to do to operate in this kind of environment, you don't get that until you're in that environment. So I think that's really important.
Yeah, part of what we're doing is the technical aspects and what we are learning from taking ourselves around the moon. The other part, obviously, is what you talked about, which is capturing the imagination of people, right? And we have far more engagement than we had hoped to have, and we hope that it will increase as we continue to take further and further steps into this mission.
Okay, we'll take our next question here in the front, and then Eric next.
Hi, Mark Kirkman with NSF. This is probably for both Judd and Howard. I'm very fascinated, we just saw some imagery of the waste dump, and I'm very fascinated with the prediction of needing the correction burns versus what's going to be the reality. I was wondering, because there's so little available material on the subsystems, at least publicly available material. Can you summarize the things other than the waste dump that would affect or perturb the trajectory? What vents off of this vehicle as opposed to what we know from shuttle like fest dumps and stuff like that? And were you surprised that you didn't need this burn? Are we tighter in the prediction than is the reality tighter than the prediction was so far?
Yeah, so two parts to that question. First, so the major contributor to dispersions is what we call them, basically unplanned little tiny jets, are the carbon dioxide scrubbers. So they vent overboard, right? Vent the CO2 overboard. And so that's it's supposed to be a non-propulsive vent, but it has some propulsion to it, just like the urine vent has a little bit of propulsion to it. And so that causes minor trajectory deviations. Were we surprised that the orbiter correction or the trajectory correction was a no-burn? No, not at all. I mean, it's well within bounds. What happens really is we have a threshold by which if the required correction is low enough, that means that our fidelity on our lowest thrusting jets, our reaction control system, it's just not worth it, right? And so we'll just build up more errors and fix it on the next trajectory correction burn.
I think it's really good to see that we don't need these minor correction burns. It shows that our navigation performance and our ability to get ranging has been outstanding, and that these venting things, whether it's wastewater or the life support CO2 venting, doesn't cause the disturbances that are greater than what we would expect in terms of our performance. And I believe, I think we might have skipped maybe two. I know we skipped one correction burn on Artemis I already. And so it's not unexpected. And so the flight control team gets an opportunity to determine when the delta V is very small, whether we actually need to execute that burn or not.
Okay, Eric, go ahead.
Eric Berger, Ars Technica. Yesterday, Howard, you made a comment about you wanted a little more humidity in the capsule, I think during the briefing, which as a Houston resident is always kind of funny to hear. But just now you mentioned that the humidity level was up and good. And maybe you could just talk about sort of the comfort in the cabin. I think there have been some questions about temperature. So kind of what temperature swings and what's the ambient temperature and sort of crew cabin comfort level?
Yeah, I'll let Judd start with the crew cabin temperature, and I can follow up. Why don't we try that?
Yeah, so we had a cabin temperature that was in the mid 70s when we first got on orbit, and then we turned off some of the shell heaters, and the temperature dropped around about 65 degrees or so. And then we understood that the crew was not comfortable at 65 degrees. So we turned some of those shell heaters on. We lowered some cabin fan speeds to try to adjust that. And we've gotten up into the low 70s, mid 70s right now. And as far as humidity, I think Howard mentioned this yesterday, but the carbon dioxide scrubbers really actually want some, a good amount of humidity so that they work effectively.
Yeah, so I'll answer, we've got a lot of different kind of knobs to turn to enable the comfort level or temperature changes. For example, the pressure vessel heaters that Judd's talking about, we can go up to 85 degrees. We're not anywhere close to that yet. So that's one knob, and we have other things where we could slow down the coolant loop speed as well in terms of how we trade the heat or the coolant that's necessary to go into the cabin as well. So a lot of different options are available. And overall, keeping a steady state relative to humidity in the cabin allows us to make sure we get good readings also from the CO2 and the CO2 scrubbing associated with that humidity.
I do want to remind us, though, that this is a part of what we want to do. We want an opportunity to be able to exercise these knobs that Howard is referring to so that we have a good characterization of the system going forward. We understand the capability of the spacecraft and its systems. This is what we want.
Okay, we'll take our next question right here.
Thank you, Mark Carreau with Aviation Week in Space Technology. I wanted to refer back to the external survey you did with solar array cameras of the Orion and the service module, just to see if you saw anything initially of concern that would have been damage to the exteriors, or it looks good.
Yeah, I have not personally seen the photos from our survey. I did watch it a little bit on TV as well, but I have not heard anything that we're concerned about, Mark. I think we will continue to go to fine detail and look at the pictures. Our thermal protection system team is doing that right now, and they'll give me a report out tomorrow morning and show me anything that they found relative to any damage. But we don't see anything relative to the back shell panels or anything like that that would cause anything of concern based on a preliminary understanding.
Okay, Jackie, go ahead.
Hi, Jackie Waddles, CNN. Thanks for doing this. Quick question for Judd or Howard. I understand that during the latest communication with crew, they were talking about mopping up some kind of leak with towels. I'm not sure I understood exactly what was going on. I'd love some insight there. And then tomorrow, there's a couple of things on the schedule I'd love to hear more about with this manual piloting, test flight test objective, and a selfie moment. I'd love some insight into what's going on there. Thanks so much.
Sure. So mopping up water. So it's not uncommon for whenever they're filling drink bags for a little bit of water to come out. The particular incident I think that the crew was talking about likely was as we were filling the contingency water bags. Whenever we had to fill them, there's a straw and a syringe, and you put a towel around it to make sure water didn't come out. There's also a feature of the potable water dispenser such that when you turn the valve off, it still dribbles out water for a little bit. So those are probably the couple of things that they're talking about. As far as tomorrow's objectives, manual piloting, so we're going to do 2 different modes. It's called 6 DOF and 3 DOF, 6 degrees of freedom and 3 degrees of freedom. It's different thruster modes of how much control that you have in all the axes and translation. So we're just going to, it's another test objective of how the vehicle handles. And selfie, I think that's probably a selfie of the Orion vehicle with the cameras.
Yeah, very similar to what we did on Artemis 1, where we had, I think, the biggest selfie stick in the world and allowed us to take all those beautiful pictures. We were originally intended to have those solar array cameras do the survey that Mark was referring to that we did today. But because we were performing so well that we were able to use one of the arrays as a selfie stick, and so that was terrific.
All right, we'll head to the phone bridge for a few questions. Our first question there is from Joseph Howlett with Scientific American.
Hi, Joseph Howlett here, Scientific American. I'm curious about how the crew is faring on board, how their spirits are. I was surprised that they only got to talk to their family now, and how did those conferences go?
Yeah, so we'll say a little bit about that. They are in great spirits, and they are really excited about the opportunity to be there and what's going on. Obviously, they've been very, very busy the first couple of days, especially leading up to translunar injection. But now that we've gotten through that, that's why there's been an opportunity for them to do things like have a conversation with their families. And in terms of the great things that are going on, they did get awakened this morning with a song called In a Daydream by the Freddie Jones Band. So there's a lot of fun things going on in addition to a lot of hard work.
Okay, our next question on the phone bridge is from Micah Maidenberg with the Wall Street Journal.
Hey, I just had a couple of quick ones for Judd. Judd, I wanted to make sure I understood this lunar science observation period. So during that 6-hour period, that's when Orion's traveling around the far side of the moon for the entire stretch of that, or not? And do you know approximately when on Monday that 6-hour period begins, like in Eastern or Central Time? Thanks so much.
Yes, I can get that for you. As far as what we're doing, it's essentially when we start our closest approach to the moon. It's pretty much the entirety of that day we'll be able to see the moon, and so what we're doing is we're doing visual observations, taking camera shots of the moon and the like. As far as when we start it, it's going to be UTC of around 1830 UTC on the 6th. So subtract 5, that's 1330 Central Time, and it'll be going on for most all of that day, right? Because they'll be at their closest approach and pretty close thereabouts during that entire time.
Okay, we'll take one more question on the phone bridge and then back here in the room. Our next question is from Marcia Dunn with the Associated Press.
Oh, hi. Thanks for taking this. Probably for you, Judd. NOAA just issued a geomagnetic storm watch, G2, coronal mass ejection. I know you guys are watching this throughout the mission, but will this one, it doesn't seem to be too bad, but will the crew be doing any precautionary measures because of this? And same question from yesterday. What's the latest revised numbers for closest approach to the moon, all the numbers and distances? Thank you.
All right. Yes. So we do have our radiation specialists that monitor all of that stuff, and if any of the sunspot coronal mass ejections happen from the sun, if they get to be a concern, then obviously we have mitigations, radiation shelters we put up. We do not expect that from this one, but we are continually monitoring that. As far as the updated numbers, I've got in statute miles, should be 252,757 statute miles at our furthest distance from the Earth.
You're not going to convert that to nautical miles?
I think Howard's got an app for that.
Yeah.
Okay, we'll take our next question right here. Go ahead.
Hi, Lauren Grutch from Bloomberg. Thanks so much. I just wanted to go back to that helium issue you were talking about earlier. You said you isolated that one branch. Just wondering if there's any concern if the second branch that you're relying on now has a similar issue, or is that redundancy you mentioned earlier, would that kick in for this problem? And then I've just been listening to the loops, and it sounds like there have been various, I guess, sensor issues or issues that are cropping up that don't seem to be an issue, like there was a suspected cabin leak, caution alarms that were coming on, but then turned out to be false alarms. I'm just curious if you're sensing any pattern with that, or is that just random glitches for a test flight like this?
Yeah, I'll start. Yeah, the other second branch on the oxidizer side is performing very well. No issues there. And so, again, that redundancy is there. And I said earlier, we do not need to regulate either on that line either for the rest of the burns. So I think both redundancy paths are in good shape. I would say, and I'll let Judd maybe talk some specifics. In general, Lakeisha said earlier, we're learning from this vehicle. And the caution warnings are based on, limits. And those limits are established jointly with the engineering team and the flight operations team. However, we have to operate in the environment. We have to, account for variations. And so I think sometimes we don't get it fully right. And when we don't, we correct it and we'll make adjustments real time where we can. And if we need to, we'll make adjustments for the future as well once we get all the data. So I think all those things are part of the learning that we're doing, and certainly good to keep the team on their toes and making sure that we're not only watching the systems very carefully, but we understand what the system is telling us, and we're adjusting based on what we understand from the data.
Yeah, and I'll add to that. So it's important to remember on Artemis I, we didn't have a caution and warning system. Because we didn't have a crew on board that we needed to alert them about, right? And so while we did measure, all of the things we did, we obviously didn't have an ECLIS system on board either, so that we knew what the behavior of that was going to be. So this is all part of exactly what Lakeisha is talking about. This is learning. This is learning how the vehicle operates with the human system in the loop, right?
Okay, we'll go to Bill next.
Hi, Bill Harwood with CBS News. This is a question I get asked a lot, and I realize that it depends on who you ask how it gets answered. But, given all the Apollo missions, the satellites that we've had around the moon at much lower altitudes than these guys are going to be at, the question I get is, what do human eyes really bring to this? Even if they've got nice cameras in their hands, they're a long way from the surface. I mean, 4,000 miles. What is this bringing that we don't already have from satellites and past missions? And I'm not saying that as a devil's advocate. I'm curious how you frame that in terms of the priorities of the mission. Thanks.
You want me to first? I could start, yeah. So my understanding, talking with the scientists, is that your eyes, the human eyes, can resolve details much better than taking a picture and then looking at the picture, even with a telephoto lens. And so that observation that the scientists are looking for is really what's key, even from as far as away as you mentioned, 4,000 miles, there are still things that the human eye can pick up with granularity that are important to the science community. Now, I can't talk about what those specific things that the science community is looking for, but that's my understanding.
Yeah, I think I'll try to maybe repeat what I said earlier. When I tell people this, and it's really purely from a spacecraft side, when we talk about wanting to have a moon base, wanting to have people on the surface of the moon or other planets, you need a way to transport people safely to that particular domain. And to me, it's very important that we do everything we can to understand and provide that capability in a robust and reliable way. And you have to walk before you can run. And I think this is very important in our step towards exploration, is learning, as we talked about earlier with all these questions relative to our subsystems, learning about how the subsystems operate in space. How do we put people in space, especially to the moon first? We haven't done that in over 53 years. This is a whole new generation of learning that we're trying to do. Certainly we learned a lot from our Apollo, I call giants, but we have our own learning to do, and we're trying to be more capable, and we're trying to provide more numerous opportunities to go to the moon so that we can put people down on the surface.
All right, we'll take our next question right here. Go ahead.
Hi, Michael Adkison, Houston Public Media. I know you guys are all too familiar with the Apollo 8 comparisons to this mission. They obviously did their Christmas Eve broadcast, and Sunday is Easter. We're in the midst of Passover, and Ramadan even was a couple of weeks ago. Are there any plans to do any sort of downlinks to mark the occasion or anything like that?
There will be an opportunity, obviously, to hear from the crew, and we will be having a conversation in terms of what they intend to share with us. They are always inspirational in their communication with us, and we're really looking forward to that.
Okay, we'll take our next question right here in the middle.
Hi, T.G. Mascaro with the Epoch Times. Thank you so much. My question, Howard, what specific things have exceeded your expectations in terms of the Orion spacecraft?
Well, that's interesting. I would say that, just how happy and how well trained the crew is and our teams are to just work through just minor issues that we've had. To me, it's not so much an exceedance of expectation. I expect that, but just to see it in play, just to see how well that's working out. And of course, I expect our spacecraft to perform, but you never know. This is why we have a flight test, and it makes me very happy to see that although we have some minor issues to deal with, the team operates very well with the crew, both on the ground collectively between our mission evaluation room, our flight control team, and with the crew together, working together. And of course, the spacecraft is responding in a way that, of course, we knew about from Artemis I. Every spacecraft is different, but the process is the same, the rigorous testing that we do and the analysis we do. And so I would say that it's always good to beat expectations.
Richard Two of the Post newspaper. A question for Judd, talking a little bit like a different aspect of this, so that with the MCC, can you talk about so many moving parts make this mission successful coming out of that department? What's the tone and the consensus of the controllers, the directors, as they see this mission transpire, and what are they thinking as far as how things are going so far in the mission?
So my sense is that there's a lot of people that are very excited, right? And excited not only for the overall general, objective that we're going back to the moon, but also just from, there's a lot of time that people have invested in training for this mission, developing the mission, being able to work well with all of the teams together, and to see that come together. I think there's a lot of excitement there, and it shows.
Going off that question, just curious, the technology's changed so much in mission control from the Apollo days to Artemis. Is there anything that you all have learned during this mission? Have you made any changes in mission control? We see the astronauts are making changes on the fly. I'm just curious to know if any changes are being made in mission control as well. Yeah, I mean, I think you hear it in all of the
funnies we see with sensors, the way they behave, the way the systems behave, that means that we are all reacting to that, and we are developing on the fly different ways than we originally thought how we would operate the vehicle. And so that is always an iterative process, right? And I think you're seeing demonstration of that in real time, and that we're iterating on not only learning about the vehicle, but also how to iteratively operate the vehicle as well.
Okay, we'll take another question right here in the room.
Yeah, hi, Beverly Casillas for Space Scout. Thanks again for doing this. Two quick questions. The first one, so we heard that the optical communications demo is already being used to downlink some imagery from the spacecraft. It sounds like that happened overnight. Are there any plans to potentially do any transmission of live video during the mission? And is that something we would get to see, if so? And then a second question, because it sounds like Orion's maneuvering has been really precise during the mission so far, what are you hoping to learn during this mission about guidance and navigation and PNT in the lunar environment? And is there anything that you're kind of already learning about that process? Thanks.
So I'll take the first part. For optical comm, the way the trajectory is set up, unfortunately, the only passes that we have with Goldstone are when the crew is asleep. And so anything that we have downlinked would be just video that you're already kind of seeing, higher resolution of the spacecraft looking back at either the moon or the Earth. And so for that purposes, we're really going to just use it for high-res video downlink. And then your second question.
I think I'll take the.
Yeah, why don't you take that? Yeah.
Can you repeat your second question? I think you said something. Perked my ears. Guidance, navigation, control. So. Yeah. Can you
yes.
repeat that, please?
Yeah, I was just saying, because we've seen how precise the kind of trajectory planning has already been with, not needing to do this correction burn, have you been having any learnings already about navigation and PNT with the Orion spacecraft and like ground systems during this mission? And is there anything at the moon that you're also hoping to kind of learn and experience on that front?
So, we're using very traditional navigation instruments, so star trackers, the inertial measuring units I talked about yesterday. I think those are, we expect them to be precise. They're tried and true navigation instruments or sensors that are on a lot of spacecraft across the board. I think one of the things that we may have not talked about a lot is we have a capability on Orion to navigate without ground comm. And that's the optical comm system, optical navigation system. And that's a camera-based system that gives you a really good enough navigation knowledge, to be able to return the crew home and perform the mission. And so that's something that's a new capability that we're very interested in. I know the navigation team is certainly very interested. We did do some testing on Artemis I, and we learned a lot from that. We'll learn a lot from this, because it basically takes pictures and translate that size of the moon or the Earth, depending on which way you're pointed, and gives you navigation knowledge from that. So again, that's a tool that we expect. And of course, as an old controls guy, control systems, ability to have good latency or no latency potentially, and ability to fire the jets when you need them, the combination jets you need them based on your offset center of gravity and where you are in terms of your mass properties, are really a great knowledge across the board of understanding. We put a lot of effort into protecting for a lot of dispersions, as Judd's talked about previously. And of course, when we encounter those dispersions, being able to control our spacecraft through them is really important as well. So all that we'll be learning. We will learn a lot, even though we have very good instruments, even though we know we have good control laws, we've implemented algorithms. Every mission is a great learning event, and it's really great to see that the precision of the work we put in is being replicated on orbit.
And I would add to that, in addition, as good as the sensors are on Orion, we still have to do ranging of the vehicle to update its state knowledge every once in a while. And so, as a lessons learned from Artemis I, we have a new suite of tools on the ground that are able to process that ranging data, and also to hopefully, what we're hoping to learn is to back out all of those, minor dispersions from, non-propulsive events that are a little bit propulsive, so that we understand that can characterize all of the error sources of the navigation state.
Okay, we'll take another question here in the room, and then we'll go back to our phone bridge. Go ahead.
Thank you. Tarek Malik with Space.com. I think for Judd, there was discussion yesterday about how Flight Day 3 was a big change of pace for the crew after the first kind of action-packed couple days. And I'm really curious how, I know they had CPR demos today, they had lunar science preps today, how that change has gone. And then I know that tomorrow, they've got some scheduled time, at least 20 minutes, to take photos of celestial bodies. And I'm just curious, if it's not the Earth and the Moon, what else might they be taking pictures of out the window in their personal time there? Thanks.
Yeah, I mean, I think you probably saw in some of the videos, the crew has a lot more time on their hands than they did in the first days. We were able to present them to you and have them talk to the media. As far as the pace, yeah, I think you can probably tell from the downlinks that the pace is quite different than it was the first couple of days. As far as celestial, I mean, they're taking pictures of stars and moon and sun, right? So anything they can see that is of interest.
Okay, we'll head back over to our phone bridge. Our next question is from David Denault with About Space Today News. Go ahead.
I'd like to do a follow-up regarding the cabin temperatures. Has NASA determined a desired temperature and a desired humidity, and is there any relationship to that with the carbon dioxide?
As far as the desired cabin temperature, that is up to crew discretion, right? And so we're simply going off of what feels best to them as a consensus for the 4 members of the crew members. Humidity, we have to have some amount of humidity. I think we mentioned earlier for the carbon dioxide, we don't want it to be Arizona dry, I think is the term to use. We certainly want, but obviously the crew doesn't want it to be Houston humid either, right? So.
Yeah, that's about right. Yeah. About 70s and about 25%, somewhere around there. Yep, they're comfortable.
Okay, we'll take another question from our phone bridge. Our next one is from Allison McGraw. Go ahead.
Hi, Dr. Allison McGraw, Mysterious Meteorites. Congratulations on the continued success from the giant leap for planetary science. My question is, given the crew's training with the CLO, or Crew Lunar Operations, what geology or image targets are first to be taken of during the lunar flyby? Thank you.
I think we heard your conversation about images supporting geology. Yeah, so the crew is definitely going to be preparing themselves during the lunar flyby and during the time that they are going around the moon to take images. They are actually working now with the science team that has gotten underway, and they are doing preparations and working together to figure out what will be of interest and what they expect to see on Flight Day 6. And so that coordination continues as guided by our science team.
Okay, we'll go ahead and come back here to the room. If I can get a show of hands, how many more questions we have. Okay, we'll jump right over here. We'll take a few on this side, and then we'll come back over to this side.
Hello, Dan Lenahan from the Naval Postgraduate School. You've talked about this mission being a flight test program and an envelope expansion. And with the importance of the International Space Station, can you maybe talk about how the systems in Orion were originally kind of tested out prior to this mission in order to kind of succeed?
Yeah, I'll start with the Universal Waste Management System, or the toilet. The same toilet was flown on Space Station. I think the crews there were able to operate it for roughly about 2 weeks, if I remember. And so that was a really good, important test in a relevant environment against our toilet that we would be able to fly to the moon with. So that's one piece. I don't think there's probably smaller equipment, like, for example, the CO2 removal system. The heart of it is these amine beads. They absorb CO2 and then we vent it out. The same technology is on the space station. Different way on how they approach it, but very similar in terms of absorbing and desorbing of the CO2 that comes from us humans. And that was also a really good foundation to stand on in our confidence associated with ability to remove CO2, although in a different manner on board our spaceship. So those are probably the big items that I would translate between what we've learned from Space Station and what we've applied for Orion.
Okay, we'll take our next question right here and then right behind you after.
Thank you. Jonathan Seri with Fox News. I'm interested in the medical equipment on board. How did the CPR demonstrations go? How did the other demonstrations go? And then if you could explain Avatar. I understand what it is, but I don't understand how the chips interact with the cell samples. If you could school me on that.
So they haven't done the CPR demo as of yet, or at least as I started the conference. So that's later on today. Avatar.
So we don't have a science representative here with us today, but as best I understand that Avatar is actually analog tissue samples from the crew members, and they have been brought on board, and there's going to be an expectation that they'll be evaluating those samples for how they react to the environment while they are on this mission, including reaction to exposure to radiation as well. And so when it gets back, we'll be very interested to understand what they learned, both from the crew themselves as well as their avatars.
And Jonathan, if you need anything else on that, we can get it to you after the press conference.
Thank you. Thank you.
Robert Coppinger, the British Interplanetary Society's Spaceflight magazine. Do you have any information on the status of the CubeSats that were deployed?
Sure. All 4 CubeSats were successfully deployed on the planned timeline about 5 hours after launch. There has been positive communication with 2 of the CubeSat satellites, the one from Saudi Arabia as well as the one from Argentina. And then in terms of how they're faring, at this point, it would definitely be best to reach out to the payload owners in terms of how they're doing. But they absolutely were deployed as expected.
Okay, we'll take another question over here, and then we'll head back over to the right side of the room.
Hi, Katrina Miller from the New York Times. Any milestones we can expect for the rest of today? What are you 3 focused on for the latter half of day 3?
Sure. As was previously mentioned, we have the CPR demo. We'll have another press conference with the crew. They'll go look at do their med kit evaluations of what they have on board. Also, we have, as far as communications with the Deep Space Network, we're going to test out again the emergency comm mode in a more deliberate fashion. And I believe Jeremy has a press conference with so it's a CSA press conference, and then some more planned medical conferences.
Okay, we'll take our next question from Will. Go ahead.
Hi, Will Robinson Smith with Spaceflight Now. Thank you all for the time today. Question for Howard. It might be a little bit early to ask this, but from the performance you've been seeing in Orion so far on hardware and a software side, do you foresee any notable changes or updates to hardware or software for the Orion spacecraft that will fly Artemis II at this point, besides the heat shield, of course? And then the images that we've seen so far for whoever wants to take this, so far have come from Reed Wiseman. Don't know if that's just happenstance or, if the other crew members are getting good pictures, but will we see a variety of the photography skills in the days to come? How is that kind of being decided and divvied up at this point? Thanks.
All right, I'll take your first question. I think walking into this meeting, or this mission, and hearing from you here relative to just the software changes we're talking about are going to be caution warning for sure. The limits that we put on, we're going to learn a lot from this mission. So there's going to be, I call them software. You probably don't think of them as software, but really data values for limits. So those will be changing for sure. We have not seen any issues with our flight software, the actual code itself. Of course, we'll learn a lot more as we go forward next few days. Hopefully we'll find nothing. But we don't, we'll make some adjustments if we need to for Artemis III. Our software development is still a few months ahead of us in terms of completing it. We've got a lot of the software done already. Of course, we've got a lot of software from Artemis II. From a hardware perspective, there's a lot of learning. These, I would say, minor issues that we've encountered and these isolation valves, et cetera, we're going to go check those out and try to get the root cause. And if we have any things that impact our ability to fly at Artemis III, we will work that.
Hey, Howard, why don't you also touch on the different camera capabilities to include the mobile phone cameras, et cetera?
Yeah, so from an image perspective, before maybe Judd talks about who's going to take pictures, if you might or may not know that we have iPhones on board for the crew members, and they're able, not only the Nikon D5s and the Z9s that we have on board that we preloaded already, they were able to also take some iPhones as well. That's what Lakeisha's referring to. And so they'll get some great images from all those cameras. And I'll let Judd talk about who gets assigned the best pictures. I don't know.
Yeah, I mean, I think it's probably just happenstance that you've seen, Reed's pictures. Every one of them are going to be taking pictures, and I'm sure once we get, are able to downlink all of the pictures, I think you will see a suite of pictures from all of the crew members.
Okay, it looks like we have one more in the room. Do we have? Okay, we'll go ahead and take one from you, and then we'll head back over here. Thanks.
Hello, Kaya Burgess from the Times of London. Moon. Is there any plan in the future to try and overcome that for future missions, to try and use kind of satellites at Lagrange points or wherever it might be, so that in future that communication behind the moon will be possible and you will never be out of signal in the future? Obviously, it's been possible for Chinese missions that have landed landers on the far side. Is that something that you will be looking into?
So I'll just mention, as part of the administrator's Ignition initiative, he has talked about all kinds of different capabilities that we are going to try to add in a stepped approach to include capabilities on the surface on the moon, as well as communication capabilities. And relay capabilities will be absolutely a part of that for supporting us in the future.
Okay, we have another question right here. And do we have any additional questions after this one? All right, one last question in the room.
Thank you. Rod Powell at Astra Magazine. Similar question. How long do you expect the blackout to be during the flyby? And given that there's no burn back there, is there any reason to be chewing our pencils? And is there anything to learn from the timing when they come back out and you reacquire signal? Thank you.
So as to your second question, no, physics takes over, and physics will absolutely get us back to the front side of the moon. Let's see, I don't think I have the timing yet on this for how long we're going to be out of comm, but I can get you that.
Is it about 40 minutes?
Yeah, it's around.
Somewhere in that vicinity? Mm-hmm.
Yes, it is 40 minutes. All right, well, it looks like that's all the questions we have for today. Thank you so much for joining. We'll see all of you back here again tomorrow at 4:15 for our next mission status briefing. As always, you can keep up with all the latest news and events during the Artemis II mission at nasa.gov. Thanks for joining.
Hi, everyone, and welcome back to Artemis Mission Control here at Johnson Space Center in Houston, Texas. This view coming to you live from one of the solar array wing cameras on the Orion spacecraft, looking at the European Service Module and the Orbital Maneuvering System engine, also known as the OMS. We are 1 day, 21 hours, and 49 minutes into the Artemis II mission, the first flight of humans aboard the Orion spacecraft. Orion and her crew, Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen, are now 111,482 statute miles from Earth and continuing to increase that distance as we continue to grow closer to the moon, 153,763 miles away. We've just wrapped up our daily press conference, during which mission management is able to answer questions from the media. We have another one of those scheduled for tomorrow afternoon at 3:30 p.m. Eastern Time. We're live here in Mission Control Houston 24/7, providing updates as the crew continues their work aboard the Orion spacecraft. One of the most major events for today was the OTC-1 burn. That was the Orbital Trajectory Correction 1 burn. That was timelined to happen at 5:49 p.m. Central Time. However, that burn has been canceled because there is no need to correct the trajectory of Orion at this time. That burn follows the translunar injection burn at 6:49 p.m. last night. The translunar injection burn took us out of high Earth orbit and sent us toward the moon. It also commits us to a splashdown on flight day 10. Because that burn was so precise, teams were able to cancel the OTC-1 burn today. And a quick correction, the briefing for tomorrow afternoon is at 5:15 p.m. Eastern. This is the channel you'll need to look for that on, and we will continue our communications and coverage on our second YouTube stream. However, we are back here with the crew for the rest of the day. They woke up at 12 p.m. Central Time and have since then configured the cabin. They also spoke with the teams on the ground for the daily planning conference, and we got some great views inside the cabin. With that burn cancellation for today, the crew now has a little more free time on their schedule after having a very, very busy first 2 flight days with launch on April 1st and translunar injection burn on April 2nd. They do have a handful of timelined events for today, however, including filming a video of the potable water dispenser. This is how the crew accesses water during the mission. There are 4 water tanks on Orion, and they are able to fill drink bags as well as rehydrate the food that they eat while on the mission. As this is the first time we have crew living and working in Orion, the team's timelined an event for them to video themselves filling up those drink bags, filling up a rehydratable food bag to help us understand how the system is working in orbit. They will review that video once the crew has returned to Earth. There are a handful of medical devices on the spacecraft as well, and so other things the crew will be working on today is checking out those medical devices. One of those is the electrocardiogram device. They'll be able to check that out on one of their fellow crew members. Later on in the day, they will also activate and check out other diagnostic devices of the Orion medical kit system, including the blood pressure monitor, thermometer, stethoscope, and otoscope. And staying in that medical timeline, the crew will also be conducting a CPR demonstration. They'll be using their medical emergency procedures to simulate methods to treat an airway obstruction if one were to occur on Orion. A key feature of many of these events, as mentioned with the potable water dispenser, is that these will need to be recorded. These will serve as training videos and also help teams on the ground learn how to best prepare the spacecraft for future missions. Later this evening, it looks like about 10 p.m. Central Time, the crew will also work on configuring the cabin for lunar flyby. Now, they will deconfigure it because flyby is not until flight day 6, but this gives them an opportunity to practice their positioning throughout the cabin as they prepare for flyby.
Integrity, Houston, with a status and a timeline, Delta.
Go ahead, Chris.
All right, we wanted to let you know that we are stepping into our burn cancellation procedure here from the ground. We have attempted to suppress any expected caution and warnings associated with that. Just want to give you a heads up. And then we'll let you know when we have a new active burn plan. The other piece is we'd like you to give us a call prior to the CPR demo. Consider that a hard scheduled activity for now so that we can position the saws. How copy?
Copy all, and let me know when you're ready for me to start exercise.
All right, Reed, I will let you know.
As previously mentioned, we are expecting the crew to get into the CPR demo later today. That won't be until just before 7 p.m. Central Time, but the team on the ground has asked the crew to let them know before they start that demo so they can park the solar arrays. Reed Wiseman also called down that he is standing by to begin exercise. That's another opportunity for the team to park the solar arrays, and by doing so, it keeps any movement that happens inside the spacecraft from damaging those arrays. We did see some movement yesterday while Commander Reed Wiseman was exercising. The crew uses a small flywheel device. It only weighs about 30 pounds in comparison to over 4,000 pounds of equipment on the space station. And the crew is timelined to exercise for 30 minutes a day to help maintain their bone and muscle strength. This, a live view of the Artemis Flight Control Room here at Johnson Space Center. Down toward the bottom of your screen, Capcom Chris Birch, NASA astronaut who you've been hearing speaking with the crew, and next to her, Capcom and Canadian Space Agency astronaut Jenny Gibbons, also a backup flight crew member for Artemis II. Near the top of the screen, Flight Director Jeff Radigan, and to his left, Flight Director Diana Trujillo. On the left side of your screen, a live view from the Orion spacecraft, now over 112,000 miles away from Earth. And that is our little crescent Earth over to the right.
Integrity with a mag stowage follow-up for Christina.
Go ahead.
Christina, in your last report, we copied 2 levels of containment for those mags, and we need 3. So our suggestion was to put in a trash bag, if able, or another Ziploc, unless you can correct me and say we've got 3 levels of containment.
We'll go. Thank you.
Thank you much. And Integrity, read is go for exercise. We are configured.
Just as everything is properly and precisely tracked aboard Orion, there are procedures for everything as well. So whenever disposing waste, the crew is calling down, they need to track exactly where that is stowed and how. Even for Commander Reed Wiseman cleaning the windows last night, there are specific ways to take care of all systems aboard the spacecraft, and so it's important that the crew checks with the ground to make sure that they are properly caring for Orion.
Chris, I copy on exercise. I'll be starting in about 5 minutes.
Copy, sounds good.
Commander Reed Wiseman calling down that he is planning to start exercise pretty soon, and yesterday we did see some motion as he was exercising. We will look for that again here on the left side of your screen, a view from Orion looking at the European service module and that orbital maneuvering system engine. Again, we don't expect to fire the orbital maneuvering system engine again after the translunar injection burn. That was the final major burn for that engine. But this is the engine that would be used should we have an abort of the mission. However, everything's still looking great for Orion and for our 4 astronauts on the Artemis II mission.
Integrity regarding the enabled caution ORD guide unconverged. Unexpected from us down here, probably related to our recent burn plan uplinking. No crew action. And as we're performing an attitude maneuver, we're going to need Reed to stand down from his exercise until we can get the saws repositioned.
We copy standing down from exercise and copy your words about the caution as well.
Those calls to the crew as they received a caution on their displays for orb guidance. That's due to the cancellation of this orbital trajectory correction burn. No action called to the crew. Again, we canceled that orbital trajectory, outbound trajectory correction burn due to having such a precise translunar injection burn. This other burn today would have only been 8 seconds long and was deemed unnecessary. As we are currently maneuvering the attitude of Orion, Commander Reed Wiseman was also asked to hold on beginning his exercise due to the need to maneuver the solar arrays as well. They will then park those solar arrays and put Orion in the proper configuration for Wiseman to begin exercise. Mission Planning Officer here in Artemis Flight Control in Houston, Texas, reports that the crew is go for exercise as the solar arrays are now in place. We'll be looking to see if there's any movement while Commander Reed Wiseman begins his exercise portion. Orion is currently 113,922 miles away from our home planet, 152,000 miles away from the moon. Capcom Chris Birch also called up confirmation about that caution that the crew received about orb guide that was due to the cancellation of the outbound trajectory 1 burn. And of course, no action for the crew. Canadian Space Agency astronaut Jeremy Hansen answering Capcom Chris Birch's call to conduct an AGA reading. That's an anomaly gas analyzer reading. That device must be powered on 5 minutes prior to taking a reading, and they request that the crew does so before exercising. Obviously, this is the first flight of humans on this spacecraft, and therefore it's also the first flight of an ECLIS system, environmental control and life support system. By taking these readings inside the cabin, teams on the ground are able to determine how that ECLIS system is functioning and what amount of gases are inside the cabin. The numbers you heard Hansen reporting are in parts per million. This is Artemis Mission Control. As you can see, some motion on your screen from this camera on the solar array wing looking back at Orion. We are expecting that to be from Commander Reed Wiseman, exercising yet again. The crew's timeline to exercise 30 minutes each during this mission. This keeps their bones and muscles strong while in the microgravity environment. This type of motion doesn't damage the spacecraft, but the solar array wings are locked and parked to keep them from being damaged by any loads imparted from this movement. This is Artemis Mission Control, 1 day, 22 hours, and 37 minutes into the flight of Orion and the Artemis II crew. NASA astronaut and commander of the mission, Reed Wiseman, continues to exercise on the flywheel device inside Orion. That's why you're seeing some of that motion right there. And earlier today, the team decided to cancel the outbound trajectory correction 1 burn. This was going to be a small burn to keep Orion on the path to fly around the moon. However, our translunar injection burn was so precise that this correction burn was not necessary. So the crew has a little bit of free time back on their day. Coming up in just a couple of hours, the crew will get into their midday meal. The food the astronauts eat plays a key role in maintaining their health and ensuring they can perform their mission objectives to the best of their abilities, and it's also something they enjoy sharing together. Long before launch, our teams here at Johnson Space Center start preparing, so this crew has everything they need to enjoy their meals. Let's take a look.
Around the moon meal.
Around the moon meal. What would you eat? Cheese? You think?
Oh my gosh. That's clever. What do you think?
That's good. My name is Christina Cook.
And I'm Jeremy Hansen. We're crew members on the Artemis II mission flying around the moon. And when we fly around the moon, of course, we're going to be taking some food with us.
That's right. This is how to eat in space. Here we are in what we call our food lab at NASA Johnson Space Center. We come in here quite often to sample space food. The neat thing about the food selection is it is so diverse. Different entrees that you wouldn't imagine can be rehydrated and actually good in space are completely fair game. And it's pretty awesome.
We came in for Artemis to do this. We got about halfway through the first session and we're like, we're not really sure we're going to have time on board to warm this stuff up. We talked a lot about day 1. It's a long day. It's hours before we even leave the launch pad on our way to space. And then when we get to space, we have a lot of important events that day. We just did a sim yesterday where lunch is scheduled. It's
midday meal.
Yeah, midday meal for all 4 of us. And so those would be great moments, I think, in our mission to have prepped some food and sit down or float as a crew and just have a joint meal.
For sure.
I think that'd be fun.
My name is Shulei Wu. I'm the food system manager for ISS and Artemis. The food lab at Johnson Space Center, that's where we make and package most of the space food, and also where we will be making all the food for the Artemis missions. Food is a big part for our crew members. They provide the nutrition, the calorie, micronutrient for crew members, but also boosting crew morale. It's very important. There is always a lot of steps, very strict steps for us to follow to making sure the food we provide are consistent and meet all the food safety, nutritional requirements, and most important, also need to taste good. The other strategy is always promote the variety, because everybody's food preference can be very different. Therefore, the more variety we can have, the better to meet the needs of the astronaut group.
They bring out these little tiny samples of each food, and you're like, oh my gosh, I thought we were having lunch. And then by the end, there's so many space foods, and every time you leave, you're like, I am so full.
I'm so full, I'm in pain.
And you just rate them like, I love this, I don't want to eat it, I'd eat it if you tell me I need it. Because what the food lab does is they take all your preferences, but they're also like good parents and are like, you need a well-balanced diet.
Exactly. They were like, no, you can't have mac and cheese every day, Christina. Sorry.
I'm Wyeth McKinley. I'm a flight controller and a crew instructor for Artemis II. We're here at the Space Vehicle Mock-Up Facility at Johnson Space Center. We're inside the Orion mock-up where we perform crew training for the Artemis II mission. On the Orion vehicle, crew is able to heat up their food using our briefcase-style food warmer. The food is held in contact with the central heater plate by these springs so that it can warm up and they can have a delicious meal. Much of the food and drink that's on Orion is rehydratable. And so crew at our potable water dispenser will fill up their food and drink, and then at that point, you go ahead and pop it into your food warmer.
I'm kind of envisioning there's maybe one person putting the stuff in and out, kind of tossing it out to everyone as it's done. Or maybe if we're not scheduled together, you're just on your own over there, popping some things in. Or maybe just in your 2 minutes of free time between things, you're kind of getting it ready so it has time to warm up. We'll see.
Eating together really resonates with me. I think it's just a human thing to break bread together and to enjoy that necessary thing you have to do, the thing you should be grateful for. And so doing that as a group, as a family, has always been meaningful for me.
Absolutely. It represents togetherness and something a little out of the ordinary. You don't necessarily get to have those meals with everybody in your life, but if you are sharing a meal, especially if you're sharing breakfast, lunch, and dinner with a group of people, that means something. It's like a camping trip.
This is Artemis Mission Control, just a little inside look at some of the food flying aboard the Orion spacecraft with the crew. Today for lunch, the crew has a variety of options. Some of the things they'll be enjoying include beef stew, smoked turkey, chicken with peanut sauce, roasted turkey. They have cheese tortellini, butternut squash, cauliflower and cheese, and of course a fruit salad in there too. The motion you see of Orion on your screen is due to the exercise from NASA astronaut and Artemis II Commander Reed Wiseman. He continues to use the flywheel device inside the spacecraft. Again, we have each of the astronauts timelined to exercise for 30 minutes each day. Elsewhere in the cabin, Christina is working with the ECG device. As we discussed, the crew are performing checkouts of some of their medical equipment today. This is the electrocardiogram device checkout. This is, of course, with the crew being the first humans to fly aboard Orion, the first opportunity that all systems and teams have to check out their devices and hardware with humans on the spacecraft. Everything we do on this mission informs our plans for future missions around the moon. This is Artemis Mission Control. Again, the movement you see on your screen is due to Commander Reed Wiseman exercising inside the Orion spacecraft. That's a view from a solar array wing camera looking at the European service module, that large thruster in the middle, the OMS engine, the Orbital Maneuvering Services engine. We were expecting to have an outbound trajectory correction burn today at 5:49 p.m. Central Time. However, that burn was deemed unnecessary due to our precise trajectory thanks to the translunar injection burn. Earlier this morning, during the daily planning conference, Wiseman called down his thanks to the FIDOs, the Flight Dynamics Officers, for their excellence in that burn. Once he's complete with exercise, Wiseman is also timelined to work on his National Geographic filming. Again, we selected National Geographic through a competitive selection process to help us document and tell the story of the Artemis II mission. The crew members have time throughout the day scheduled to help capture those items, and a shot list provided by National Geographic with everything from exercise to family life, bedtime preparations, what it's like to live in space. They'll also explore the medical kit, which we've discussed today, and take plenty of photos, including just some memories of their time aboard Orion.